Do you know the history and quality of the top foods on your favorite food list? Today, we dive deep into one of the most remarkable vegetables ever cultivated by humankind, broccoli, the green crown of nutrition. Please let us know in the comments where you are watching this history video and what time you are watching it, and be sure to subscribe to our channel for more history videos in the future. Now, close your eyes for a moment and imagine a world without broccoli. Imagine your dinner plate missing that familiar cluster of dark green florets. Imagine your stir fry without that satisfying crunch. Imagine your steamer basket sitting empty on a cold winter evening. For many of us, broccoli is simply a part of life. It sits in our refrigerators, it fills our grocery carts. It appears on restaurant menus and school lunch trays, but broccoli was not always here. It was not always part of the human diet. In fact, broccoli as we know it today is the result of thousands of years of cultivation, selection, and patience by ancient farmers who saw potential in a wild, weedy plant growing along the rocky coastlines of the Mediterranean Sea. This is the story of broccoli. This is the story of how a humble wild cabbage became one of the most celebrated vegetables on the planet. This is a story of science, history, culture, nutrition, and the extraordinary journey of a plant that has traveled across oceans and continents to land on your plate. Let us begin at the very beginning. Long before recorded history, long before the first cities were built, long before humans learned to write or forge metal tools, there existed a scraggly, unremarkable wild plant known to botanists as Brassica oleracea. This plant grew in the limestone cliffs and coastal regions surrounding the Mediterranean basin. It was a hardy species, capable of surviving in poor soil, tolerating salt spray from the ocean, and enduring the hot, dry summers that define the Mediterranean climate. Its leaves were thick and waxy, designed to retain moisture. Its flowers were small and yellow, blooming in clusters that attracted bees and other pollinators. This wild plant did not look like broccoli. It did not look like cabbage or cauliflower or Brussels sprouts either, and yet remarkably, all of these vegetables descend from this single wild ancestor. Brassica oleracea is the mother of an entire family of vegetables that have fed billions of people throughout history. Through careful and deliberate selective breeding over many centuries, ancient farmers transformed this one wild species into a dazzling array of different crops. They selected plants with large leaves, and those became kale and collard greens. They selected plants with tightly packed leaf buds, and those became cabbage. They selected plants with swollen stems, and those became kohlrabi. They selected plants with dense flower clusters, and those became broccoli and cauliflower. This process of selective breeding is one of the greatest achievements in the history of agriculture. It did not happen overnight. It did not happen in a single generation. It was a slow, patient process that unfolded over hundreds and even thousands of years. Farmers would observe their crops, notice which plants had the most desirable traits, save seeds from those plants, and replant them the following season. Over time, these small changes accumulated, and entirely new vegetables emerged from a single ancestral species. Broccoli is one of the crown jewels of this ancient breeding process. The word broccoli itself comes from the Italian word broccolo, which means the flowering crest of a cabbage. This in turn is derived from the Latin word brachium, meaning arm or branch, a reference to the branching shape of the vegetable's flower head. When you look at a head of broccoli, you can see why this name was chosen. The thick central stalk rises from the ground and then branches out into smaller stalks, each topped with a dense cluster of tiny flower buds. These buds, if left unharvested, would eventually open into small yellow flowers, just like those of the wild Brassica oleracea ancestor. But ancient farmers discovered that if they harvested the flower head before the buds opened, the result was a tender, flavorful, and nutritious vegetable. This discovery was the birth of broccoli. The earliest cultivation of broccoli is believed to have taken place in the region that is now Italy, specifically in the areas surrounding the central and southern parts of the Italian peninsula. The Etruscans, an ancient civilization that flourished in what is now Tuscany and neighboring regions before the rise of Rome, are often credited with being among the first people to cultivate broccoli and other members of the cabbage family. The Etruscans were skilled farmers and horticulturists who developed sophisticated techniques for growing a wide variety of crops. However, it was the ancient Romans who truly embraced broccoli and helped spread its cultivation throughout the Mediterranean world. Roman writers and naturalists documented the use of broccoli-like vegetables in their works. Pliny the Elder, the great Roman naturalist and author who lived in the 1st century of the Common Era, wrote about a vegetable that closely matches the description of broccoli. In his monumental work Naturalis Historia, Pliny described a plant from the cabbage family that was prized for its tender flowering heads. He noted that this vegetable was commonly grown in gardens and was considered a delicacy among the Roman elite. The Romans had a deep appreciation for vegetables. Unlike some ancient cultures that viewed meat as the only food worthy of the upper classes, Roman cuisine celebrated the diversity of the garden. Vegetables were featured prominently in Roman banquets, and skilled Roman cooks developed elaborate recipes for preparing them. Broccoli was typically boiled or steamed and then dressed with olive oil, wine, and various spices. Roman diners ate broccoli both as a side dish and as a main course, often pairing it with fish, grains, or legumes. One of the most fascinating aspects of Roman broccoli cultivation is the fact that the Romans understood the relationship between broccoli and other members of the cabbage family. They recognized that broccoli, cabbage, cauliflower, and kale were all related plants, and they experimented with crossbreeding different varieties to create new and improved cultivars. This level of horticultural sophistication was remarkable for the ancient world and speaks to the Romans' deep understanding of agriculture and plant biology. As the Roman Empire expanded, so too did the cultivation of broccoli. Roman soldiers, traders, and colonists carried seeds and agricultural knowledge with them as they traveled across Europe, North Africa, and the Near East. Broccoli was introduced to new regions and new climates, and local farmers adapted the crop to their specific growing conditions. In this way, broccoli began its long journey from a regional Italian vegetable to a global dietary staple. After the fall of the Western Roman Empire in the 5th century of the Common Era, much of the agricultural knowledge accumulated by the Romans was preserved by monasteries and religious communities. Monks and nuns tended gardens where they grew a wide variety of vegetables, herbs, and medicinal plants. Broccoli was among the crops cultivated in these monastic gardens, and the knowledge of how to grow and prepare it was passed down through generations of religious communities. During the Middle Ages, broccoli remained primarily an Italian vegetable. While other members of the cabbage family, such as cabbage itself and kale, spread widely across northern Europe, broccoli remained concentrated in Italy and the surrounding Mediterranean region. This was partly due to climate. Broccoli prefers cool, moist growing conditions, but it is also sensitive to extreme cold. The mild Mediterranean climate of Italy was ideal for broccoli cultivation, while the harsh winters of northern Europe made it more difficult to grow. Italian farmers continued to refine and improve their broccoli varieties throughout the Middle Ages and into the Renaissance. Different regions of Italy developed their own distinctive broccoli cultivars, each adapted to local growing conditions and culinary preferences. Calabria, a region in the southern tip of the Italian peninsula, became particularly famous for its broccoli. In fact, broccoli is sometimes referred to as Calabrese in honor of this region's long and distinguished history of broccoli cultivation. Calabrese broccoli, with its large, dark green heads and thick stems, is the variety most commonly found in supermarkets today. The Renaissance was a period of enormous cultural, artistic, and scientific advancement in Italy, and it also marked a turning point in the history of broccoli. As Italian culture influenced the rest of Europe, Italian cuisine began to gain a wider audience. Wealthy families in France, England, and other countries employed Italian cooks, and these cooks brought their knowledge of broccoli and other Italian vegetables with them. One of the most important figures in the spread of broccoli beyond Italy was Catherine de' Medici, a member of the powerful Medici family of Florence. When Catherine married Henry II of France in 1533, she brought with her a large retinue of Italian cooks, gardeners, and other servants. These Italians introduced many Italian foods and culinary techniques to the French court, including broccoli. Catherine de' Medici was known for her love of fine food and her insistence on having the best Italian vegetables at her table. Through her influence, broccoli began to gain acceptance among the French aristocracy. However, broccoli's acceptance in France and other parts of Europe was slow. Many Europeans were suspicious of unfamiliar vegetables, and broccoli's unusual appearance did not help matters. Some people found the dense clusters of green flower buds unappealing, while others were simply accustomed to eating cabbage and kale and saw no reason to try a new vegetable. It would take several more centuries before broccoli achieved widespread popularity outside of Italy. In England, broccoli was introduced in the early 18th century. Early references to broccoli in English literature describe it as Italian asparagus or sprout cauliflower, reflecting the English understanding of the vegetable as an Italian import that was related to the more familiar cauliflower. English gardeners experimented with growing broccoli in their kitchen gardens, and by the middle of the 18th century, broccoli had become a reasonably well-known vegetable among the English upper classes. Philip Miller, the renowned English botanist and gardener who served as the chief gardener of the Chelsea Physic Garden in London, wrote extensively about broccoli in his influential work, The Gardener's Dictionary, first published in 1731. Miller described several varieties of broccoli and provided detailed instructions for growing them. He noted that broccoli was best planted in rich, well-drained soil and that it should be harvested before the flower buds opened. Miller's work helped popularize broccoli among English gardeners and contributed to the vegetable's gradual spread across the British Isles. Now let us turn our attention to the biology of broccoli, because understanding the science behind this vegetable is essential to appreciating its remarkable qualities. Broccoli belongs to the species Brassica oleracea and is classified in the Italica cultivar group. It is a member of the Brassicaceae family, also known as the cruciferous family or the mustard family. This is one of the most important plant families in the world, both ecologically and economically. The Brassicaceae family includes more than 3,000 species distributed across 370 genera. In addition to broccoli, this family includes cabbage, cauliflower, Brussels sprouts, kale, collard greens, kohlrabi, turnips, radishes, horseradish, mustard, watercress, arugula, and canola, among many others. The name cruciferous comes from the Latin word cruciferi, meaning cross-bearing, a reference to the four-petaled flowers of plants in this family, which are arranged in the shape of a cross. This distinctive flower shape is one of the defining characteristics of the Brassicaceae family and is shared by all of its members, including broccoli. Broccoli is a biennial plant, meaning that in its natural life cycle, it takes 2 years to complete its growth and reproduction. In the first year, the broccoli plant grows a rosette of large, dark green leaves and develops the dense flower head that we harvest and eat. If the plant is left in the ground and allowed to continue growing into the second year, the flower head will elongate, the individual buds will open into small yellow flowers, and the plant will eventually produce seeds. However, in commercial agriculture, broccoli is treated as an annual crop and is harvested in its first year, before the flower buds have a chance to open. The part of the broccoli plant that we eat is the immature flower head, also known as the curd or simply the head. This head is composed of thousands of tiny, tightly packed flower buds, each of which is attached to a small stem. Together, these buds and stems form the characteristic tree-like shape of a broccoli floret. The main stem of the broccoli plant is also edible and is often overlooked by consumers. The stem has a milder flavor than the florets and a crisp, slightly sweet taste when properly prepared. Broccoli plants typically grow to a height of 60 to 90 centimeters, although some varieties can grow taller. The leaves are large, with a blue-green color and a slightly waxy texture. The flower head is usually dark green, although some varieties produce heads that are purple, white, or even yellow-green. The size of the head varies depending on the variety, growing conditions, and harvest timing, but a typical head of broccoli weighs between 300 and 500 grams. Broccoli is a cool season crop that grows best in temperatures between 15 and 20 degrees Celsius. It can tolerate light frosts but is damaged by prolonged freezing temperatures. High temperatures cause broccoli to bolt or produce flowers prematurely, which results in loose, open heads with a bitter flavor. For this reason, broccoli is typically planted in early spring or late summer, depending on the climate, so that it matures during the cooler months of the year. The growing cycle of broccoli from seed to harvest typically takes between 70 and 100 days, depending on the variety. Seeds are usually started indoors or in a greenhouse and then transplanted to the garden or field when the seedlings are 4 to 6 weeks old. Broccoli prefers rich, well-drained soil with a pH between 6 and 7. It is a heavy feeder, meaning that it requires generous amounts of nitrogen, phosphorus, and potassium to produce a good crop. Regular watering is also important, as broccoli plants have shallow root systems and are susceptible to drought stress. After the main head is harvested, many broccoli varieties will produce smaller side shoots or sprouting broccoli from the leaf axils along the main stem. These side shoots can be harvested over a period of several weeks, extending the productive life of the plant. This characteristic makes broccoli an excellent crop for home gardeners who can enjoy multiple harvests from a single planting. Now, let us explore the extraordinary nutritional profile of broccoli, because it is this aspect of the vegetable that has earned it the title of superfood in recent decades. Broccoli is one of the most nutrient-dense foods on the planet. Calorie for calorie, broccoli provides more vitamins, minerals, and beneficial plant compounds than almost any other vegetable. A single serving of broccoli, roughly 1 cup of chopped florets, contains a remarkably low number of calories while delivering an impressive array of essential nutrients. Let us start with vitamins. Broccoli is an outstanding source of vitamin C, also known as ascorbic acid. Vitamin C is a powerful antioxidant that plays a critical role in immune function, skin health, and wound healing. It is also essential for the synthesis of collagen, a structural protein that is found in skin, bones, cartilage, and blood vessels. A single serving of raw broccoli provides more than the daily recommended intake of vitamin C for most adults. This makes broccoli one of the richest plant sources of this essential vitamin, rivaling citrus fruits and bell peppers. Broccoli is also an excellent source of vitamin K, a fat-soluble vitamin that is essential for blood clotting and bone health. Vitamin K plays a critical role in the production of prothrombin, a protein that is necessary for blood to clot properly. Without adequate vitamin K, even minor cuts and injuries could result in dangerous bleeding. Vitamin K also helps regulate calcium metabolism and is important for maintaining strong, healthy bones. A single serving of broccoli provides a substantial portion of the daily recommended intake of vitamin K in addition to vitamins C and K. Broccoli provides significant amounts of several B vitamins, including folate, vitamin B6, riboflavin, thiamine, niacin, and pantothenic acid. Folate, also known as vitamin B9, is particularly important for pregnant women, as it plays a critical role in fetal development. Adequate folate intake during pregnancy helps prevent neural tube defects, which are serious birth defects that affect the brain and spinal cord. Broccoli is one of the best dietary sources of folate, making it an important food for women of childbearing age. Vitamin A is another nutrient found in abundance in broccoli. However, broccoli does not contain preformed vitamin A, which is found in animal products such as liver and eggs. Instead, broccoli contains beta-carotene, a provitamin, a carotenoid that the body converts into active vitamin A as needed. Beta-carotene is also a powerful antioxidant that helps protect cells from damage caused by free radicals. The beta-carotene in broccoli contributes to the vegetable's dark green color and is one of the many beneficial plant compounds that make broccoli such a nutritional powerhouse. Broccoli also contains small but significant amounts of vitamin E, another fat-soluble antioxidant vitamin. Vitamin E protects cell membranes from oxidative damage and plays a role in immune function and skin health. While broccoli is not as rich in vitamin E as nuts, seeds, and vegetable oils, it nonetheless contributes to overall vitamin E intake as part of a balanced diet. Moving on to minerals, broccoli is a good source of several essential minerals, including potassium, calcium, magnesium, phosphorus, iron, zinc, manganese, copper, and selenium. Potassium is an electrolyte that helps regulate fluid balance, muscle contractions, and nerve signals. Adequate potassium intake is associated with healthy blood pressure and a reduced risk of cardiovascular disease. Broccoli provides a meaningful amount of potassium per serving, making it a useful addition to a heart-healthy diet. Calcium, the most abundant mineral in the human body, is essential for strong bones and teeth, muscle function, nerve transmission, and hormone secretion. While dairy products are the best-known source of dietary calcium, broccoli is one of the best plant-based sources of this mineral. Moreover, the calcium in broccoli is highly bioavailable, meaning that the body absorbs and utilizes it efficiently. Studies have shown that the body absorbs calcium from broccoli at a rate of approximately 60%, compared to about 30% for dairy products. This high bioavailability makes broccoli an especially important source of calcium for people who do not consume dairy, such as those who are lactose intolerant or follow a vegan diet. Magnesium is another mineral found in broccoli. Magnesium is involved in more than 300 enzymatic reactions in the body, including energy production, protein synthesis, muscle and nerve function, blood sugar regulation, and blood pressure control. Many people do not consume enough magnesium in their diets, making broccoli a valuable contributor to meeting daily magnesium needs. Iron, though present in smaller amounts in broccoli compared to red meat or legumes, is nonetheless an important nutrient provided by this vegetable. The vitamin C in broccoli enhances the absorption of non-heme iron, the form of iron found in plant foods. Eating broccoli provides both iron and the vitamin C needed to absorb it, making it a particularly smart food choice for people who rely on plant-based sources of iron. Beyond vitamins and minerals, broccoli is rich in dietary fiber, both soluble and insoluble. Dietary fiber is essential for digestive health. Insoluble fiber adds bulk to the stool and helps food move through the digestive tract, promoting regular bowel movements and preventing constipation. Soluble fiber dissolves in water to form a gel-like substance that helps lower cholesterol levels and regulate blood sugar. A single serving of broccoli provides a significant amount of dietary fiber, contributing to overall gut health and digestive regularity. Broccoli is also a notable source of protein for a vegetable. While it does not provide as much protein as meat, fish, eggs, or legumes, broccoli contains more protein per calorie than most other vegetables. This protein is composed of all 9 essential amino acids, although not in the proportions needed to be considered a complete protein on its own. Nevertheless, when combined with other plant-based protein sources such as grains, legumes, nuts, and seeds, broccoli can contribute meaningfully to overall protein intake. But perhaps the most exciting aspect of broccoli's nutritional profile is its extraordinary content of bioactive plant compounds, also known as phytochemicals. These are naturally occurring chemicals produced by plants that have biological effects on the human body beyond basic nutrition. Broccoli contains a dazzling array of phytochemicals, many of which have been the subject of intensive scientific research in recent decades. The most celebrated of these phytochemicals are the glucosinolates. Glucosinolates are sulfur-containing compounds that are found in all cruciferous vegetables but are particularly abundant in broccoli. When broccoli is chopped, chewed, or otherwise physically disrupted, an enzyme called myrosinase comes into contact with the glucosinolates and converts them into biologically active compounds called isothiocyanates. The most famous isothiocyanate found in broccoli is sulforaphane. Sulforaphane has been the subject of thousands of scientific studies and is widely regarded as one of the most potent naturally occurring compounds with potential health-promoting properties. Research has shown that sulforaphane activates a network of protective enzymes in the body that help defend cells against damage from oxidative stress, inflammation, and environmental toxins. Sulforaphane works by activating a cellular pathway known as NRF2, which is sometimes called the master regulator of cellular defense. When sulforaphane activates the NRF2 pathway, it triggers the production of a cascade of antioxidant and detoxification enzymes that help protect cells from damage and promote cellular health. The discovery of sulforaphane is a remarkable story in its own right. In 1992, a team of researchers led by Dr. Paul Talalay at Johns Hopkins University isolated sulforaphane from broccoli and demonstrated its potent ability to induce protective enzymes in human cells. This groundbreaking research was published in the prestigious scientific journal Proceedings of the National Academy of Sciences and sparked a wave of interest in broccoli as a health-promoting food. Since then, hundreds of studies have investigated the effects of sulforaphane on various aspects of human health, and the results have been overwhelmingly positive. In addition to sulforaphane, broccoli contains other important isothiocyanates, including indole-3-carbinol and diindolylmethane, often abbreviated as DIM. These compounds have been studied for their potential effects on hormone metabolism, particularly estrogen metabolism. Research suggests that indole-3-carbinol and DIM may help promote the metabolism of estrogen into less potent forms, which could have implications for reducing the risk of hormone-sensitive conditions. Broccoli is also rich in flavonoids, another class of phytochemicals with powerful antioxidant and anti-inflammatory properties. The primary flavonoid in broccoli is kaempferol, which has been studied for its potential to reduce inflammation, protect against oxidative damage, and support cardiovascular health. Other flavonoids found in broccoli include quercetin, which is also found in onions, apples, and tea, and is known for its anti-inflammatory and antihistamine properties. Carotenoids are yet another class of beneficial plant compounds found in broccoli. In addition to beta-carotene, which we discussed earlier, broccoli contains lutein and zeaxanthin, two carotenoids that are particularly important for eye health. Lutein and zeaxanthin accumulate in the macula, the central part of the retina that is responsible for sharp, detailed vision. These carotenoids act as natural filters that absorb harmful blue light and protect the delicate cells of the macula from damage. Adequate intake of lutein and zeaxanthin has been associated with a reduced risk of age-related macular degeneration, the leading cause of vision loss in older adults. Now that we have explored the nutritional profile of broccoli, let us examine the health benefits that have been attributed to this remarkable vegetable. The scientific literature on broccoli and health is vast and growing, and we will touch on many of the key findings. One of the most extensively studied health benefits of broccoli is its potential role in supporting the body's natural defenses against cellular damage. The combination of antioxidants, anti-inflammatory compounds, and detoxification-promoting phytochemicals found in broccoli creates a powerful cocktail of cellular protection. Sulforaphane in particular has been shown in laboratory studies to help protect DNA from damage, reduce oxidative stress, and promote the elimination of harmful substances from the body. While much of this research has been conducted in cell cultures and animal models, and more human studies are needed, the existing evidence is promising and has generated enormous scientific interest. Broccoli's potential benefits for cardiovascular health are another area of active research. Several studies have found that regular consumption of cruciferous vegetables, including broccoli, is associated with a lower risk of cardiovascular disease. The mechanisms behind this association are thought to involve multiple factors, including broccoli's ability to lower cholesterol levels, reduce inflammation, improve blood vessel function, and protect against oxidative damage to the cardiovascular system. The soluble fiber in broccoli helps lower cholesterol levels by binding to bile acids in the digestive tract and promoting their excretion from the body. Bile acids are made from cholesterol, so when the body needs to produce more bile acids to replace those that have been excreted, it draws on its cholesterol stores, resulting in a net reduction in blood cholesterol levels. Interestingly, research has shown that the cholesterol-lowering effect of broccoli is enhanced when the vegetable is steamed rather than eaten raw. Steaming appears to increase the binding capacity of broccoli's fiber for bile acids, making steamed broccoli more effective at lowering cholesterol than raw broccoli. The potassium in broccoli also contributes to cardiovascular health by helping to regulate blood pressure. High blood pressure or hypertension is one of the leading risk factors for heart disease and stroke. Potassium helps counteract the effects of sodium on blood pressure and promotes the relaxation of blood vessel walls, leading to lower blood pressure. Increasing potassium intake through the consumption of potassium-rich foods like broccoli is one of the dietary strategies recommended by health organizations for managing blood pressure. Broccoli's anti-inflammatory properties may also benefit cardiovascular health. Chronic inflammation is increasingly recognized as a key driver of cardiovascular disease. The kaempferol and other flavonoids in broccoli have been shown to reduce levels of inflammatory markers in the blood, potentially lowering the risk of inflammation-driven cardiovascular damage. Digestive health is another area where broccoli shines. The dietary fiber in broccoli supports a healthy digestive system by promoting regular bowel movements and preventing constipation. But the benefits go beyond simple regularity. The fiber in broccoli serves as a prebiotic, meaning that it provides food for the beneficial bacteria that live in the large intestine. These beneficial bacteria, collectively known as the gut microbiome, play a crucial role in digestion, immune function, and overall health. When the gut microbiome is well fed and diverse, it produces short-chain fatty acids, such as butyrate, that nourish the cells lining the colon and help maintain the integrity of the intestinal barrier. Research has shown that sulforaphane from broccoli may also benefit digestive health by helping to maintain a healthy balance of bacteria in the stomach and intestines. Studies have found that sulforaphane can inhibit the growth of Helicobacter pylori, a bacterium that infects the stomach lining and is a major risk factor for stomach ulcers and stomach-related health issues. In clinical trials, consuming broccoli sprouts, which are particularly rich in sulforaphane, has been shown to reduce levels of H. pylori in infected individuals. Broccoli may also support bone health. As we discussed earlier, broccoli is a good source of calcium, and the calcium in broccoli is highly bioavailable. But broccoli provides several other nutrients that are important for bone health as well, including vitamin K, magnesium, phosphorus, and zinc. Vitamin K is particularly important for bone health because it is required for the activation of osteocalcin, a protein that helps bind calcium to the bone matrix. Without adequate vitamin K, calcium cannot be properly incorporated into bones, potentially leading to weakened bones and an increased risk of fractures. The combination of calcium, vitamin K, and other bone-supporting nutrients in broccoli makes it an excellent food for maintaining bone density and strength throughout life. This is particularly important for older adults who are at increased risk of osteoporosis, a condition characterized by weakened bones and an increased risk of fractures. Broccoli's potential benefits for skin health are also worth noting. The vitamin C in broccoli is essential for the production of collagen, the protein that gives skin its structure, strength, and elasticity. Adequate vitamin C intake helps maintain healthy, youthful-looking skin and supports the body's ability to repair skin damage. The beta-carotene in broccoli is converted to vitamin A in the body, and vitamin A is important for skin cell turnover and repair. Additionally, the sulforaphane in broccoli has been shown in laboratory studies to protect skin cells from damage caused by ultraviolet radiation, the primary cause of premature skin aging and sunburn. Let us also discuss broccoli's potential role in supporting the immune system. A strong, well-functioning immune system is essential for defending the body against infections, illnesses, and other threats. Broccoli supports immune function through several mechanisms. First, its high vitamin C content directly supports the immune system. Vitamin C enhances the production and function of white blood cells, which are the body's primary defense against pathogens. Second, the beta-carotene in broccoli supports the integrity of the mucous membranes that line the respiratory and digestive tracts, which serve as physical barriers against infection. Third, the sulforaphane in broccoli has been shown to boost the activity of natural killer cells, a type of white blood cell that plays a critical role in the body's innate immune response. Research has also suggested that broccoli may support healthy blood sugar regulation. The fiber in broccoli slows the absorption of sugar from the digestive tract into the bloodstream, helping to prevent the rapid spikes and crashes in blood sugar that can occur after eating high-carbohydrate meals. Additionally, sulforaphane has been shown in some studies to improve insulin sensitivity and reduce fasting blood sugar levels. A clinical trial published in the journal Science Translational Medicine in 2017 found that broccoli sprout extract containing concentrated sulforaphane significantly reduced fasting blood sugar levels in obese individuals with poorly controlled blood sugar. While more research is needed, these findings suggest that broccoli could be a valuable dietary tool for supporting healthy blood sugar metabolism. Broccoli's potential benefits for brain health are an emerging area of scientific interest. The brain is particularly vulnerable to oxidative stress, and the antioxidants in broccoli, including sulforaphane, kaempferol, and vitamin C, may help protect brain cells from oxidative damage. Animal studies have shown that sulforaphane can cross the blood-brain barrier and exert protective effects on brain cells. Some research has suggested that sulforaphane may help reduce neuroinflammation, support the growth of new brain cells, and protect against age-related cognitive decline. The kaempferol in broccoli has also been studied for its potential neuroprotective effects. Laboratory studies have shown that kaempferol can protect brain cells from damage caused by various toxins and stressors, and epidemiological studies have found that higher intake of kaempferol-rich foods is associated with better cognitive function in older adults. Now, let us shift our attention to the various ways that broccoli has been prepared and enjoyed throughout history and across different cultures. In ancient Rome, as we discussed earlier, broccoli was typically boiled or steamed and served with olive oil, wine, and spices. Roman cooks valued simplicity and quality of ingredients, and their approach to broccoli reflected this philosophy. The Roman cookbook De Re Coquinaria, attributed to Marcus Gavius Apicius, contains recipes for various cabbage family vegetables that may have included broccoli or broccoli-like vegetables. In medieval and Renaissance Italy, broccoli was prepared in a variety of ways. Italian cooks sautéed broccoli with garlic and olive oil, a simple and delicious preparation that remains popular to this day. They also added broccoli to soups, stews, and pasta dishes. Broccoli was sometimes pickled or preserved in vinegar for later use. Italian Renaissance cookbooks contain numerous recipes featuring broccoli, reflecting the vegetable's central role in Italian cuisine during this period. As broccoli spread to other parts of Europe, it was adapted to local culinary traditions. In France, broccoli was often served with butter, cream, and cheese sauces. French cuisine, with its emphasis on rich, indulgent flavors, transformed broccoli from a simple peasant vegetable into an elegant dish worthy of the finest tables. Broccoli gratins, in which the vegetable is baked with cheese and cream sauce, became a popular preparation in French cooking and have since spread to many other cuisines around the world. In England, broccoli was typically boiled until tender and served as a simple side dish. English cooks of the 18th and 19th centuries often overcooked their vegetables, and broccoli was no exception. The English tendency to boil vegetables into submission gave broccoli an undeserved reputation as a bland and mushy food. It was not until the late 20th century, when lighter cooking methods became popular, that many English-speaking populations rediscovered the joys of properly cooked broccoli. In Asian cuisines, broccoli has been enthusiastically adopted and adapted to local tastes. Chinese broccoli, also known as gailan or Chinese kale, is a related but distinct vegetable that has been cultivated in China for centuries. Gailan has thinner stems, smaller florets, and a slightly more bitter flavor than the Calabrese broccoli that is most common in Western countries. However, Western-style broccoli has also become widely popular in Chinese cooking, where it is typically stir-fried with garlic, ginger, soy sauce, and oyster sauce. The high heat of stir-frying cooks broccoli quickly, preserving its bright green color and crisp texture while developing a smoky, caramelized flavor. In Japanese cuisine, broccoli is often used in tempura, where florets are coated in a light batter and deep-fried until crispy. Broccoli is also a common ingredient in Japanese bento boxes, where small steamed or blanched florets add color and nutrition to the meal. In Indian cuisine, broccoli is used in curries, stir-fries, and rice dishes. Indian cooks season broccoli with a complex blend of spices, including turmeric, cumin, coriander, chili, and garam masala, creating dishes that are richly flavored and aromatic. In Thai cuisine, broccoli is commonly stir-fried with protein sources such as chicken, shrimp, or tofu, and seasoned with fish sauce, garlic, chili, and sugar. The balance of sweet, salty, sour, and spicy flavors that characterizes Thai cooking creates dishes where broccoli takes on an entirely new personality, far removed from the simple steamed broccoli of Western cooking. Korean cuisine also embraces broccoli, incorporating it into dishes like bibimbap, a mixed rice bowl topped with an array of vegetables, protein, and a spicy chili paste. Broccoli may also be lightly blanched and served as a side dish, dressed with sesame oil and sesame seeds. In the Middle Eastern culinary tradition, broccoli is sometimes roasted with olive oil, lemon juice, and za'atar, a spice blend that typically includes thyme, sumac, and sesame seeds. Roasting brings out broccoli's natural sweetness and creates crispy, caramelized edges that are absolutely delicious. The global spread of broccoli in the modern era is a remarkable story of agricultural innovation and international trade. In the 20th century, broccoli production expanded rapidly to meet growing demand. Italy remained a major producer, but other countries with suitable climates also began growing broccoli on a large scale. China has become the world's largest producer of broccoli by far, growing millions of metric tons of the vegetable each year. India, Spain, France, Mexico, and many other countries are also significant producers. The development of modern broccoli varieties has been driven by the needs of commercial agriculture. Plant breeders have developed varieties that produce uniform, tightly packed heads, resist common diseases and pests, tolerate a wide range of growing conditions, and have a long shelf life after harvest. These improvements have made broccoli more widely available and more affordable than ever before. Modern broccoli varieties are typically classified into three main types: Calabrese broccoli, sprouting broccoli, and purple cauliflower, which is sometimes considered a type of broccoli. Calabrese broccoli is the type most commonly found in supermarkets. It produces a single large head on a thick stalk and is harvested all at once. Sprouting broccoli produces many smaller heads on branching stems and is harvested over a longer period. Purple sprouting broccoli is a popular variety in the United Kingdom and other parts of Europe. It has a longer growing season than Calabrese broccoli and is typically harvested in late winter and early spring when few other fresh vegetables are available. Romanesco broccoli, also known as Roman cauliflower, is a visually stunning variety that produces a head composed of spiraling, fractal-like patterns of lime green florets. Romanesco is prized for its unique appearance and its mild, nutty flavor. Broccolini, sometimes marketed under brand names such as Tenderstem, is a hybrid vegetable created by crossing broccoli with Chinese broccoli or gailan. Broccolini has long, thin stems topped with small florets and has a milder, sweeter flavor than regular broccoli. It was developed in Japan in the early 1990s and has since become popular in many countries around the world. Broccoli sprouts are another innovation that has gained popularity in recent years. Broccoli sprouts are the young seedlings of broccoli plants, typically harvested when they are just 3 to 5 days old. Despite their small size, broccoli sprouts contain extraordinarily high concentrations of sulforaphane and other glucosinolates, often 10 to 100 times more than mature broccoli heads. This makes broccoli sprouts a concentrated source of the health-promoting phytochemicals that have made broccoli famous. The discovery of the extraordinary sulforaphane content of broccoli sprouts was made by the same Johns Hopkins research team, led by Dr. Paul Talalay, that first isolated sulforaphane from mature broccoli in 1992. In 1997, Dr. Talalay and his colleagues published a landmark study showing that broccoli sprouts were a far more concentrated source of sulforaphane than mature broccoli. This finding generated enormous public interest and led to a boom in the commercial production and sale of broccoli sprouts. Today, broccoli sprouts are widely available in health food stores and supermarkets and are also easy to grow at home. Let us now discuss how broccoli should be stored and prepared to maximize its nutritional value. Fresh broccoli should be stored in the refrigerator, where it will keep for about 5 to 7 days. It is best stored unwashed in a loosely sealed plastic bag in the crisper drawer. Washing broccoli before storage can promote the growth of mold and accelerate spoilage. Broccoli should be used as soon as possible after purchase, as its nutritional content begins to decline from the moment it is harvested. Studies have shown that broccoli can lose a significant portion of its vitamin C and glucosinolate content within just a few days of harvest, particularly if it is stored at room temperature. When preparing broccoli, the method of cooking has a significant impact on its nutritional value. Raw broccoli retains the highest levels of vitamin C, as this vitamin is heat-sensitive and is partially destroyed by cooking. However, raw broccoli can be difficult to digest for some people and may cause bloating and gas. Lightly steaming broccoli for 3 to 5 minutes is generally considered the best cooking method for preserving its nutritional value while improving its digestibility. Steaming retains most of the vitamin C, vitamin K, and glucosinolates while softening the fiber and making the vegetable easier to eat and digest. Boiling broccoli, on the other hand, can lead to significant nutrient losses. Water-soluble vitamins, including vitamin C and several B vitamins, leach out of the broccoli and into the cooking water. Studies have shown that boiling broccoli for 10 minutes can result in the loss of more than 50% of its vitamin C and a significant portion of its glucosinolates. If you do boil broccoli, using the cooking water in soups or sauces can help recover some of the lost nutrients. Microwaving broccoli is a quick and convenient cooking method that generally preserves nutrients well, as long as minimal water is used. The short cooking time and the fact that microwaving does not require the broccoli to be submerged in water help minimize nutrient losses. However, microwaving with large amounts of water can lead to significant losses of glucosinolates and vitamin C. Frying broccoli in a small amount of oil is another good cooking method that preserves many nutrients while adding flavor and creating an appealing texture. The high heat of stir-frying cooks the broccoli quickly, and the addition of a small amount of oil can actually enhance the absorption of fat-soluble vitamins and carotenoids. Roasting broccoli at high temperatures has become increasingly popular in recent years. Roasting caramelizes the natural sugars in broccoli, creating a nutty, slightly sweet flavor and crispy edges that are irresistible. While roasting does result in some loss of heat-sensitive nutrients, it also enhances the formation of certain beneficial compounds and makes broccoli extremely palatable, potentially encouraging people to eat more of it. Eating broccoli raw is perfectly fine and is an excellent way to maximize vitamin C intake. Raw broccoli can be enjoyed with dips, added to salads, or simply eaten as a crunchy snack. Some people find raw broccoli difficult to digest, particularly if they are not accustomed to eating raw cruciferous vegetables. If this is the case, gradually increasing intake of raw broccoli can help the digestive system adapt. One important factor that affects the formation of sulforaphane from glucosinolates is the activity of the enzyme myrosinase. Myrosinase is present in raw broccoli, but is partially or completely inactivated by cooking. This means that cooked broccoli may produce less sulforaphane than raw broccoli, since the enzyme needed to convert glucosinolates into sulforaphane has been destroyed by heat. However, research has shown that the bacteria in the human gut can also convert glucosinolates into isothiocyanates, including sulforaphane, even when myrosinase has been inactivated by cooking. This means that some sulforaphane is still produced from cooked broccoli, although the amount may be lower than from raw broccoli. A clever trick for maximizing sulforaphane production from cooked broccoli is to chop or crush the broccoli and let it sit for about 40 minutes before cooking. This allows the myrosinase enzyme to convert the glucosinolates into sulforaphane before the enzyme is destroyed by heat. Alternatively, adding a source of myrosinase to cooked broccoli, such as mustard seed powder, radish, or raw broccoli sprouts, can help restore sulforaphane formation. Freezing is another popular method of preserving broccoli. Commercially frozen broccoli is typically blanched or briefly immersed in boiling water before freezing. Blanching inactivates enzymes that can cause flavor and texture changes during storage, and it also helps preserve the bright green color of the broccoli. However, blanching also destroys myrosinase and results in some loss of water-soluble vitamins. Despite these losses, frozen broccoli is still a nutritious food and is a convenient option for people who do not have access to fresh broccoli or who want to have broccoli on hand at all times. Studies comparing the nutritional content of fresh and frozen broccoli have found that frozen broccoli retains most of its vitamins, minerals, and fiber. The glucosinolate content of frozen broccoli is also well preserved, although the inactivation of myrosinase means that less sulforaphane may be produced when frozen broccoli is consumed. As mentioned earlier, the gut bacteria can still convert glucosinolates into sulforaphane, so frozen broccoli remains a valuable source of health-promoting phytochemicals. Now, let us address some of the potential disadvantages and side effects associated with broccoli consumption. While broccoli is an incredibly nutritious food with numerous health benefits, it is not without its drawbacks for certain individuals. One of the most common complaints about broccoli is that it can cause bloating, gas, and digestive discomfort. This is due to the presence of raffinose, a complex sugar that the human body cannot digest. Raffinose passes through the stomach and small intestine undigested and is fermented by bacteria in the large intestine, producing gas as a byproduct. This can lead to bloating, flatulence, and abdominal discomfort, particularly in people who are not accustomed to eating high-fiber foods or cruciferous vegetables. The good news is that these digestive side effects typically diminish over time as the gut microbiome adapts to a higher intake of fiber and complex sugars. Gradually increasing broccoli consumption, rather than eating large amounts all at once, can help minimize digestive discomfort. Cooking broccoli can also help, as heat breaks down some of the complex sugars and fibers that cause gas. Another potential concern is broccoli's effect on thyroid function. Like all cruciferous vegetables, broccoli contains goitrogens, substances that can interfere with the thyroid gland's ability to absorb iodine and produce thyroid hormones. In theory, consuming very large amounts of raw cruciferous vegetables could suppress thyroid function and contribute to the development of goiter, an enlargement of the thyroid gland. However, this is primarily a concern for people who already have thyroid disorders or who consume inadequate amounts of iodine. For most healthy individuals, eating normal amounts of broccoli, even on a daily basis, is unlikely to have any negative effects on thyroid function. Cooking broccoli significantly reduces the activity of goitrogens, further minimizing any potential risk. People who take blood-thinning medications, such as warfarin, should be aware of broccoli's high vitamin K content. Vitamin K plays a key role in blood clotting, and sudden changes in vitamin K intake can interfere with the effectiveness of blood-thinning medications. People on warfarin are generally advised to maintain a consistent intake of vitamin K-rich foods rather than avoiding them entirely. If you eat broccoli regularly, continue to do so, but avoid dramatically increasing or decreasing your intake without consulting your healthcare provider. Some people may be allergic to broccoli, although this is rare. Broccoli allergy symptoms can include hives, swelling, difficulty breathing, and gastrointestinal distress. Cross-reactivity between broccoli and other members of the Brassicaceae family is possible, meaning that someone who is allergic to one cruciferous vegetable may also react to others. If you suspect a broccoli allergy, seek medical evaluation and guidance. Broccoli can also interact with certain medications beyond blood thinners. The high fiber content of broccoli can affect the absorption of some medications, and the phytochemicals in broccoli can influence the activity of certain enzymes in the liver that are responsible for metabolizing drugs. If you take prescription medications, it is a good idea to discuss your dietary habits with your healthcare provider to ensure that there are no significant interactions. Despite these potential drawbacks, it is important to emphasize that broccoli is safe and beneficial for the vast majority of people. The health benefits of broccoli far outweigh any potential risks for most individuals, and broccoli can be safely enjoyed as part of a balanced and varied diet. Now, let us explore some fascinating and lesser-known facts about broccoli that will deepen your appreciation for this remarkable vegetable. Broccoli is approximately 90% water by weight. This high water content makes broccoli a hydrating food that contributes to overall fluid intake. Despite being mostly water, broccoli is still packed with nutrients, which is why it is considered one of the most nutrient-dense foods available. The deep green color of broccoli is due to the presence of chlorophyll, the pigment that plants use to capture sunlight and convert it into energy through photosynthesis. Chlorophyll has been studied for its potential health benefits, including its ability to support detoxification and promote wound healing. When broccoli is overcooked, the chlorophyll breaks down and the vibrant green color fades to an olive drab, a visual cue that the broccoli has been cooked too long and has lost some of its nutritional value. Broccoli has a distinctive and somewhat pungent odor when cooked, particularly when overcooked. This odor is caused by the release of sulfur-containing compounds, including hydrogen sulfide and various organic sulfides. These compounds are produced when the glucosinolates and other sulfur-containing molecules in broccoli are broken down by heat. While some people find this odor unpleasant, the sulfur compounds that produce it are actually some of the most beneficial phytochemicals in broccoli. There is a genetic component to how people perceive the taste of broccoli. Some individuals carry a specific gene variant that makes them particularly sensitive to bitter tastes. These supertasters may find broccoli and other cruciferous vegetables to be unpleasantly bitter, which can make it difficult for them to enjoy these foods. Research has shown that the TASTOR38 gene, which codes for a bitter taste receptor, plays a significant role in determining how people perceive the taste of cruciferous vegetables. People who carry 2 copies of the taster variant of this gene are more likely to dislike broccoli, while those who carry 2 copies of the non-taster variant are more likely to enjoy it. This genetic variation in taste perception may help explain why some people love broccoli while others detest it. It also has implications for public health, as people who are genetically predisposed to dislike bitter vegetables may consume less of these nutritious foods, potentially missing out on their health benefits. Researchers are exploring strategies for overcoming genetic taste aversions, including pairing bitter vegetables with sweet or savory flavors, using different cooking methods that reduce bitterness, and gradually introducing bitter foods in small quantities. Broccoli is a surprisingly good source of omega-3 fatty acids for a vegetable. While the amounts are small compared to fatty fish or flaxseed, broccoli does contain alpha-linolenic acid, a plant-based omega-3 fatty acid that the body can convert, albeit inefficiently, into the longer-chain omega-3 fatty acids EPA and DHA. Every little bit helps, and the omega-3 content of broccoli is one more reason to include it in your diet. The environmental footprint of broccoli is relatively low compared to many other foods, particularly animal products. Growing broccoli requires significantly less water, land, and energy than producing meat, dairy, or eggs. Broccoli also produces fewer greenhouse gas emissions per unit of nutrition than most animal-based foods. Choosing to eat broccoli and other vegetables in place of higher-impact foods is one of the simplest and most effective ways to reduce your personal environmental footprint. However, broccoli cultivation is not without environmental challenges. Like all agricultural crops, broccoli production requires inputs of water, fertilizer, and pesticides, and it can contribute to soil degradation and water pollution if not managed sustainably. Broccoli is also a relatively perishable vegetable that requires refrigeration during transportation and storage, which adds to its energy footprint. Organic broccoli production, which avoids synthetic pesticides and fertilizers, can help reduce some of these environmental impacts, although organic farming typically produces lower yields and may require more land. Let us now discuss some of the cultural significance and symbolism of broccoli. In many cultures, broccoli has come to symbolize health and nutrition. It is often used as a visual shorthand for healthy eating, appearing in advertisements, educational materials, and media campaigns promoting the consumption of fruits and vegetables. The image of a bright green broccoli floret is instantly recognizable and universally associated with nutritious food. Broccoli has also been the subject of considerable controversy and humor, particularly in the context of children's eating habits. Many children are famously resistant to eating broccoli, and the struggle between parents who want their children to eat vegetables and children who refuse is a common theme in family life, popular culture, and even political discourse. One of the most famous political moments involving broccoli occurred in 1990, when a prominent world leader publicly declared his dislike of broccoli and banned it from being served in his official residence. This declaration sparked a national debate about broccoli and generated enormous media attention. Broccoli farmers responded by sending truckloads of broccoli in protest, and the incident became a defining cultural moment that actually boosted public awareness of and interest in broccoli. Sales of broccoli reportedly increased in the wake of the controversy, as many people rallied to the vegetable's defense. In Japanese culture, broccoli has been embraced as a popular vegetable for bento boxes and everyday cooking. The Japanese appreciation for the visual appeal of food extends to broccoli, whose bright green color and tree-like shape make it an attractive addition to arranged meals. In recent years, broccoli has become one of the most popular vegetables in Japan, and Japanese plant breeders have developed numerous varieties suited to local growing conditions and culinary preferences. In Chinese culture, broccoli is considered a health-promoting food that is associated with vitality and well-being. Chinese traditional medicine classifies broccoli as a cooling food that can help balance the body's internal heat. While these traditional classifications do not always align with modern nutritional science, they reflect a long-standing cultural appreciation for the healthful properties of broccoli and other cruciferous vegetables. Let us now return to the science of broccoli and explore some of the cutting-edge research that is being conducted on this vegetable. One of the most exciting areas of current research involves the potential of sulforaphane to support the body's natural detoxification processes. Every day we are exposed to a wide range of environmental pollutants, including air pollution, heavy metals, pesticides, and industrial chemicals. The body has sophisticated detoxification systems that help neutralize and eliminate these harmful substances, and research suggests that sulforaphane can enhance the efficiency of these systems. A landmark clinical trial conducted in China's Jiangsu province, published in the journal Cancer Prevention Research in 2014, found that participants who consumed a broccoli sprout beverage rich in sulforaphane excreted significantly higher levels of certain airborne pollutants, including benzene and acrolein, compared to participants who consumed a placebo beverage. This study provided some of the strongest evidence to date that sulforaphane can enhance the body's ability to detoxify environmental pollutants, and it has important implications for populations living in areas with high levels of air pollution. Another fascinating area of research involves the potential of broccoli to support mental health. Preliminary studies have suggested that sulforaphane may have mood-enhancing properties and could potentially benefit individuals with mood-related conditions. Animal studies have shown that sulforaphane can reduce behaviors associated with depression and anxiety, potentially by reducing neuroinflammation and oxidative stress in the brain. While human studies are still in the early stages, the initial results are intriguing and have sparked significant interest in the mental health community. Research on broccoli and gut health is also advancing rapidly. The gut microbiome, the complex community of trillions of bacteria that inhabit the digestive tract, is increasingly recognized as a key determinant of overall health. Broccoli and other cruciferous vegetables appear to have a particularly beneficial effect on the gut microbiome. Studies have shown that the fiber and phytochemicals in broccoli promote the growth of beneficial bacterial species while inhibiting the growth of harmful ones. The short-chain fatty acids produced by the fermentation of broccoli fiber in the gut have anti-inflammatory and gut protective properties that are essential for maintaining a healthy digestive system. A study published in the Journal of Functional Foods in 2017 found that participants who consumed cooked broccoli daily for 18 days experienced significant changes in the composition of their gut microbiome, with increases in beneficial bacterial species associated with improved metabolic and immune health. These findings suggest that regular broccoli consumption can positively shape the gut microbiome and contribute to better overall health. Research into broccoli's potential effects on aging is another exciting frontier. The sulforaphane in broccoli has been shown to activate cellular processes that are associated with longevity and healthy aging. One such process is autophagy, the cellular housekeeping mechanism by which cells break down and recycle damaged or dysfunctional components. Autophagy is essential for maintaining cellular health and function, and its decline with age is thought to contribute to the aging process and the development of age-related diseases. Sulforaphane has been shown to stimulate autophagy in various cell types, potentially helping to slow the aging process and extend healthy lifespan. The NRF2 pathway, which is activated by sulforaphane, is also associated with longevity. NRF2 activation enhances the body's antioxidant and anti-inflammatory defenses, which can help protect against the accumulated cellular damage that drives aging. Animal studies have shown that enhanced NRF2 activity is associated with longer lifespan and reduced age-related disease, and researchers are investigating whether dietary strategies that activate NRF2, such as consuming broccoli, could have similar benefits in humans. Let us also explore the agricultural science behind broccoli production, because the story of how broccoli gets from the farm to your table is a remarkable journey in itself. Modern broccoli production is a highly sophisticated operation that combines traditional farming practices with cutting-edge technology. Broccoli is grown on farms ranging from small family operations to large commercial enterprises that span thousands of hectares. The choice of variety, planting date, spacing, fertilization, irrigation, and pest management all have a significant impact on the quality and yield of the broccoli crop. Broccoli seeds are typically started in nurseries or greenhouses, where they are grown under controlled conditions until the seedlings are large enough to be transplanted to the field. Transplanting rather than direct seeding is the preferred method for most commercial broccoli production because it allows for more uniform stands, earlier harvesting, and better weed management. Transplants are set in the field at carefully calculated spacing, typically about 45 to 60 centimeters apart within the row and about 60 to 90 centimeters between rows. Broccoli is a relatively demanding crop in terms of nutrient requirements. It requires generous applications of nitrogen, phosphorus, and potassium to produce high-quality heads. Nitrogen is particularly important for broccoli, as it promotes vigorous leaf growth and supports the development of the flower head. Too little nitrogen results in small, thin heads with poor color, while too much nitrogen can promote excessive leaf growth at the expense of head development and can also increase the plant's susceptibility to certain diseases. Irrigation is another critical factor in broccoli production. Broccoli plants have relatively shallow root systems and are sensitive to both drought stress and waterlogging. Consistent moisture is essential for producing high-quality heads with uniform florets. Many broccoli farms use drip irrigation or overhead sprinkler systems to provide a steady supply of water to the crop. Pest and disease management is a significant challenge in broccoli production. Broccoli is susceptible to a wide range of insect pests, including aphids, caterpillars, flea beetles, and root maggots. Aphids are particularly problematic as they can infest the dense flower heads and are difficult to remove once they are embedded among the florets. Caterpillars, including the larvae of the cabbage white butterfly, can cause significant damage by feeding on the leaves and flower heads. Integrated pest management strategies, which combine cultural practices, biological control agents, and judicious use of pesticides, are the preferred approach for managing insect pests in broccoli production. Diseases can also pose a significant threat to broccoli crops. Common diseases include black rot, a bacterial disease that causes V-shaped yellow lesions on the leaves; downy mildew, a fungal disease that causes yellow patches on the upper leaf surface and grayish-white mold on the underside; clubroot, a soil-borne disease that causes swollen, distorted roots; and head rot, which can occur when bacteria or fungi infect the dense flower head, causing it to decay. Disease management strategies include planting disease-resistant varieties, practicing crop rotation, maintaining proper drainage, and applying fungicides or bactericides when necessary. Harvest timing is critical for broccoli quality. Broccoli heads should be harvested when the buds are tightly closed and the head is firm and compact. If harvesting is delayed even a few days, the buds may begin to open and the head will become loose and open-textured, a condition known as riciness or flowering out. Once the buds open, the quality of the broccoli declines rapidly, and the head is no longer suitable for sale. Broccoli is typically harvested by hand, as the heads mature at different rates even within a single field. Skilled harvest workers walk through the field, identify heads that are ready for harvest, and cut them from the plant with a sharp knife. The harvested heads are placed in bins or crates and transported to a packing facility where they are cooled, trimmed, sorted, and packed for shipping. Rapid cooling is essential for maintaining the quality and extending the shelf life of harvested broccoli. Broccoli is highly perishable and will begin to deteriorate within hours if left at field temperature. Most broccoli packing facilities use hydrocooling, where the broccoli is immersed in or sprayed with near-freezing water, or forced air cooling, where refrigerated air is blown through the broccoli containers. These cooling methods rapidly reduce the temperature of the broccoli to near 0 degrees Celsius, slowing respiration and metabolic processes and extending shelf life to 2 to 3 weeks under proper refrigeration. The development of the cold chain, the system of refrigerated transportation and storage that allows perishable foods to be shipped long distances while maintaining quality, has been instrumental in making broccoli available year-round in markets around the world. Before the advent of modern refrigeration, broccoli could only be enjoyed in season and in the regions where it was grown. Today, broccoli is shipped by refrigerated truck, train, ship, and even airplane from production regions to markets thousands of miles away. This brings us to an important discussion about the global broccoli market. Broccoli is one of the most widely traded vegetables in the world, with a global market valued at billions of dollars. The leading broccoli-producing countries include China, India, Spain, Mexico, Italy, France, Poland, the United Kingdom, and many others. China alone accounts for a significant portion of global broccoli production, reflecting the enormous scale of Chinese agriculture and the growing domestic demand for broccoli in the Chinese market. International trade in broccoli is facilitated by advances in refrigeration technology, transportation infrastructure, and global supply chain management. Fresh broccoli is exported from producing countries to markets around the world, while frozen broccoli is traded even more extensively, as its longer shelf life and lower transportation costs make it a more practical option for long-distance trade. The rise of organic broccoli production is another important trend in the global broccoli market. Consumer demand for organic produce has grown dramatically in recent decades, driven by concerns about pesticide residues, environmental sustainability, and health. Organic broccoli is grown without synthetic pesticides or fertilizers and is produced according to strict standards that promote soil health, biodiversity, and ecological balance. Organic broccoli typically commands a premium price compared to conventionally grown broccoli, reflecting the higher production costs and lower yields associated with organic farming. Let us now talk about broccoli in the context of broader dietary patterns and nutritional guidelines. Broccoli is a key component of several dietary patterns that have been associated with good health and longevity. The Mediterranean diet, which is based on the traditional eating patterns of countries bordering the Mediterranean Sea, features an abundance of vegetables, including cruciferous vegetables like broccoli. The Mediterranean diet has been extensively studied and has been linked to reduced risk of heart disease, diabetes, cognitive decline, and other chronic conditions. Broccoli fits perfectly into this dietary pattern, providing a wealth of vitamins, minerals, fiber, and phytochemicals. The DASH diet, which stands for Dietary Approaches to Stop Hypertension, is another evidence-based dietary pattern that emphasizes the consumption of vegetables, fruits, whole grains, and lean protein while limiting sodium, saturated fat, and added sugars. The DASH diet has been shown to effectively lower blood pressure and reduce the risk of cardiovascular disease. Broccoli's high potassium content, low sodium content, and abundance of other heart-healthy nutrients make it an ideal food for people following the DASH diet. Plant-based dietary patterns, including vegetarian and vegan diets, also feature broccoli prominently. For people who do not consume animal products, broccoli is an important source of calcium, iron, protein, and other nutrients that might otherwise be lacking in the diet. The high bioavailability of calcium from broccoli is particularly important for vegans who do not consume dairy products and must rely on plant-based sources of calcium. Broccoli is also a popular food among athletes and fitness enthusiasts. Its high nutrient density, low calorie content, and abundance of vitamins and minerals make it an ideal food for supporting athletic performance and recovery. The vitamin C in broccoli supports immune function, which can be compromised by intense exercise. The potassium helps maintain proper fluid balance and prevents muscle cramps. The fiber promotes digestive health and helps maintain a feeling of fullness, which can be beneficial for athletes who need to manage their weight. The concept of eating the rainbow is a popular nutritional guideline that encourages people to eat fruits and vegetables of many different colors, as different colored foods contain different phytochemicals and nutrients. Broccoli represents the green component of the rainbow and provides a unique set of nutrients and phytochemicals that are not found in the same concentrations in other colored vegetables. By eating broccoli along with red tomatoes, orange carrots, yellow bell peppers, blue blueberries, and purple eggplant, you can ensure a diverse and comprehensive intake of beneficial plant compounds. Let us also explore some creative and innovative ways that broccoli is being used in modern cuisine and food technology. Broccoli rice has become a popular low-carbohydrate alternative to traditional grain rice. To make broccoli rice, raw broccoli florets and stems are pulsed in a food processor until they resemble the texture of rice grains. The broccoli rice can then be sautéed, steamed, or microwaved and used as a base for stir-fries, grain bowls, and other dishes. Broccoli rice provides a fraction of the carbohydrates and calories of grain rice while delivering a much higher concentration of vitamins, minerals, and phytochemicals. It has become a staple of low-carb, keto, and paleo diets and is now available pre-packaged in many supermarkets. Broccoli soup is another popular preparation that showcases the vegetable's versatility. Cream of broccoli soup, in which cooked broccoli is blended with cream, butter, and seasonings, is a classic comfort food that has been enjoyed for generations. Modern variations include dairy-free broccoli soups made with coconut milk or cashew cream, as well as lighter versions that rely on the natural creaminess of pureed broccoli without any added fat. Broccoli pesto is an innovative twist on traditional basil pesto. Steamed or blanched broccoli is blended with garlic, nuts, Parmesan cheese, olive oil, and lemon juice to create a vibrant green sauce that can be tossed with pasta, spread on sandwiches, or used as a dip. Broccoli pesto is a delicious way to increase vegetable intake and introduces broccoli to people who might not otherwise eat it. Broccoli smoothies may sound unusual, but they are an increasingly popular way to incorporate this nutritious vegetable into the diet. Raw or lightly steamed broccoli can be added to fruit smoothies without significantly affecting the flavor, as the sweetness of the fruit masks the taste of the broccoli. A broccoli smoothie made with banana, mango, spinach, and a splash of orange juice provides an enormous dose of vitamins, minerals, and phytochemicals in a convenient, drinkable form. Broccoli chips and crisps are another modern innovation. Broccoli florets are thinly sliced, seasoned with olive oil and spices, and baked or dehydrated until crispy. The result is a crunchy, savory snack that is far more nutritious than traditional potato chips. Broccoli chips are available commercially in many markets and are also easy to make at home. Fermented broccoli is a traditional preparation in some cultures and is gaining popularity among health-conscious consumers. Fermenting broccoli with salt and water creates a tangy, probiotic-rich food that combines the nutritional benefits of broccoli with the gut health benefits of fermentation. The fermentation process may also enhance the bioavailability of certain nutrients and phytochemicals in broccoli. Broccoli is also being explored as an ingredient in plant-based meat alternatives and other processed food products. Food scientists are investigating ways to use broccoli protein, fiber, and other components as functional ingredients in novel food products. Broccoli powder, made by drying and grinding broccoli into a fine green powder, is used as a nutritional supplement and as a natural food coloring agent. In the world of scientific research, broccoli continues to be the subject of intense investigation. New studies are published every year exploring the health effects of broccoli and its phytochemicals, and our understanding of this vegetable's benefits is constantly evolving. Recent research has explored the potential of broccoli-derived compounds for supporting liver health, promoting healthy aging, supporting joint health, and even enhancing the effectiveness of certain medical treatments. One particularly intriguing area of research involves the potential of sulforaphane to cross the blood-brain barrier and exert protective effects on the brain. Animal studies have shown that sulforaphane can reduce brain inflammation, protect against oxidative damage, and improve cognitive function. These findings have led researchers to investigate whether sulforaphane could be beneficial for individuals with neurodegenerative conditions, although clinical trials in humans are still in the early stages. Another cutting-edge area of research involves the use of broccoli sprout extracts as a topical treatment for skin conditions. Preliminary studies have shown that sulforaphane-rich broccoli sprout extracts can protect skin cells from ultraviolet radiation damage when applied topically. This has led to interest in developing broccoli-based skincare products that could provide natural sun protection and anti-aging benefits. Let us also consider broccoli in the context of food security and sustainable agriculture. As the global population continues to grow, there is an increasing need for nutritious, sustainably produced foods that can feed more people with fewer resources. Broccoli has several characteristics that make it a promising crop for addressing food security challenges. It is highly nutritious, providing an enormous amount of vitamins, minerals, and beneficial phytochemicals per unit of land, water, and energy used to produce it. It can be grown in a wide range of climates and soils, making it adaptable to many different agricultural settings. And it can be preserved by freezing, drying, or other methods, extending its availability and reducing food waste. However, broccoli also faces challenges in the context of food security. It is a relatively labor-intensive crop that requires significant inputs of water, fertilizer, and pest management. Climate change poses a threat to broccoli production, as rising temperatures and changing precipitation patterns can affect yields and quality. In some regions, water scarcity and drought are already limiting the expansion of broccoli production. Plant breeders are working to develop new broccoli varieties that are more resistant to heat, drought, and pests, and that can produce high yields under a wider range of growing conditions. These efforts are essential for ensuring that broccoli remains a widely available and affordable food in the face of a changing climate. Vertical farming and controlled environment agriculture are emerging technologies that could revolutionize broccoli production in the future. By growing broccoli in indoor facilities with precisely controlled temperature, humidity, light, and nutrient levels, it is possible to produce high-quality broccoli year-round, regardless of outdoor weather conditions. Vertical farms use significantly less water and land than traditional agriculture and can be located in urban areas, reducing the transportation distance between farm and consumer. While the energy costs of indoor farming are currently high, advances in LED lighting technology and renewable energy are making this approach increasingly viable. Hydroponic and aeroponic growing systems, in which plants are grown without soil using nutrient-rich water solutions, are also being used for broccoli production. These systems offer precise control over growing conditions and can produce broccoli faster and more efficiently than traditional soil-based agriculture. Hydroponic broccoli can be grown in greenhouses, vertical farms, or even in home garden setups, making it accessible to a wide range of growers. We have covered an enormous amount of ground in this first part of our documentary, from the ancient origins of broccoli along the Mediterranean coast to the cutting-edge science that is revealing new health benefits every day. We have explored broccoli's extraordinary nutritional profile, its rich cultural history, its journey from Italy to the rest of the world, and the many ways it can be prepared and enjoyed. We ended part 1 by reflecting on the extraordinary genetic journey that transformed a wild coastal plant into the broccoli we know today. Now, let us take a closer look at the science of broccoli genetics and breeding, because this is one of the most fascinating and rapidly advancing areas of broccoli research. The genome of Brassica oleracea, the species to which broccoli belongs, was fully sequenced in 2014 as part of an international collaborative effort involving researchers from multiple countries. The sequencing of the broccoli genome was a landmark achievement that opened new doors for understanding the genetic basis of broccoli's traits, including its nutritional content, disease resistance, growth habits, and flavor. The Brassica oleracea genome contains approximately 45,000 protein-coding genes distributed across 9 chromosomes, making it a moderately complex genome by plant standards. One of the most remarkable features of the Brassica oleracea genome is evidence of multiple whole genome duplication events in its evolutionary history. Whole genome duplication, in which the entire genetic content of an organism is copied, is a relatively common phenomenon in the plant kingdom and has played a major role in the evolution of plant diversity. In the case of Brassica oleracea, at least 3 rounds of whole genome duplication have occurred over the course of its evolutionary history, resulting in a genome that contains many duplicated genes. These duplicated genes have provided the raw material for evolutionary innovation, allowing different copies of the same gene to evolve new functions over time. This genetic redundancy may help explain the extraordinary morphological diversity of Brassica oleracea, which has given rise to such dramatically different vegetables as broccoli, cabbage, cauliflower, Brussels sprouts, kale, and kohlrabi. Traditional broccoli breeding relies on the principles of selective breeding that have been practiced for thousands of years. Plant breeders cross-pollinate broccoli plants with desirable traits, grow the offspring, evaluate their characteristics, and select the best individuals for further breeding. This process is repeated over many generations, gradually concentrating desirable traits and eliminating undesirable ones. Traditional breeding has been remarkably successful in improving broccoli varieties, producing cultivars with larger heads, more uniform maturity, better disease resistance, improved flavor, and longer shelf life. One of the major achievements of traditional broccoli breeding has been the development of hybrid varieties. Hybrid broccoli varieties are created by crossing 2 genetically distinct parent lines, a process that results in offspring with hybrid vigor or heterosis. Hybrid vigor is the tendency of hybrid offspring to be more vigorous, productive, and uniform than either of their parents. Hybrid broccoli varieties typically produce larger, more uniform heads, mature more consistently, and are more resistant to diseases and environmental stresses than open-pollinated varieties. The development of hybrid broccoli in the mid-20th century was a major milestone in broccoli breeding and contributed significantly to the expansion of commercial broccoli production. However, hybrid varieties also have drawbacks, because hybrid offspring do not breed true, meaning that their seeds do not produce plants identical to the parents. Farmers who grow hybrid broccoli must purchase new seeds each season from the seed company. This creates a dependency on commercial seed producers and increases the cost of production. Open-pollinated broccoli varieties, by contrast, produce seeds that breed true, allowing farmers to save and replant seeds from their own crops. For this reason, some small-scale and organic farmers prefer open-pollinated varieties, despite their generally lower yields and less uniform appearance. Modern broccoli breeding increasingly relies on molecular tools and techniques. Marker-assisted selection is a technique in which DNA markers linked to desirable traits are used to identify promising plants at an early stage, before the traits are visually apparent. This allows breeders to select plants more efficiently and accelerate the breeding process. Genomic selection, a more advanced technique, uses information from the entire genome to predict the performance of individual plants and select the best candidates for breeding. These molecular breeding approaches are making it possible to develop improved broccoli varieties faster and more precisely than ever before. One of the most exciting applications of modern genetics in broccoli breeding is the development of varieties with enhanced nutritional content. Researchers have identified the genes responsible for the production of glucosinolates, carotenoids, vitamins, and other beneficial compounds in broccoli, and they are working to develop varieties with higher concentrations of these compounds. A particularly notable example is the development of super broccoli varieties with elevated levels of glucoraphane, the glucosinolate precursor of sulforaphane. These super broccoli varieties contain 2 to 3 times more glucoraphane than standard broccoli and are designed to deliver greater health benefits to consumers. The development of super broccoli began in the early 2000s at the Institute of Food Research in Norwich, England, under the leadership of Professor Richard Mithen. Mithen and his colleagues identified wild Brassica oleracea populations from Sicily that naturally contained high levels of glucoraphane. They crossed these wild plants with commercial broccoli varieties using traditional breeding techniques, eventually producing a new variety with significantly elevated glucoraphane content. This variety was commercialized under the brand name Beneforte and is now available in supermarkets in several countries. Clinical trials have shown that consuming Beneforte broccoli results in higher levels of sulforaphane in the blood compared to standard broccoli, suggesting that it may provide enhanced health benefits. Gene editing technologies such as CRISPR-Cas9 are also being explored as tools for improving broccoli. CRISPR-Cas9 allows scientists to make precise, targeted changes to an organism's DNA without introducing foreign genetic material. This technology could potentially be used to enhance broccoli's nutritional content, improve its resistance to diseases and pests, increase its tolerance to environmental stresses, and extend its shelf life. While gene-edited broccoli is not yet commercially available, research in this area is progressing rapidly and could lead to significant advances in the coming years. It is worth noting that all of the broccoli breeding work described above, including the development of super broccoli, uses traditional breeding techniques or targeted genetic modifications that build on natural genetic variation within the Brassica oleracea species. The development of broccoli as a crop has always been a process of harnessing natural genetic variation through human selection, and modern breeding tools are simply accelerating and refining this ancient process. Now let us turn our attention to the environmental dimensions of broccoli production, a topic of growing importance in an era of climate change and environmental awareness. Broccoli production, like all agriculture, has an environmental footprint. Growing broccoli requires land, water, energy, and other inputs, and it can generate waste and pollution if not managed responsibly. However, compared to many other food products, particularly animal-based foods, broccoli has a relatively modest environmental impact. Water use is one of the most significant environmental considerations in broccoli production. Broccoli is a moderately water-intensive crop, requiring approximately 40 to 80 centimeters of water over the course of its growing season, depending on the climate, soil type, and irrigation method. In arid and semi-arid regions, where water is scarce and irrigation is essential, broccoli production can place significant demands on limited water resources. In some of the world's major broccoli-producing regions, competition for water between agriculture, urban use, and environmental needs is a growing source of tension. Efficient irrigation technologies, such as drip irrigation, can significantly reduce the water footprint of broccoli production. Drip irrigation delivers water directly to the root zone of the plant through a network of tubes and emitters, minimizing water loss from evaporation and runoff. Studies have shown that drip irrigation can reduce water use in broccoli production by 30 to 50% compared to traditional flood or furrow irrigation, while maintaining or even improving yields. Soil health is another important consideration. Broccoli is typically grown in intensive monoculture systems, where the same crop is planted in the same field year after year. While this approach can maximize short-term productivity, It can also lead to soil degradation, nutrient depletion, and the buildup of soil-borne diseases and pests. Sustainable soil management practices such as crop rotation, cover cropping, composting, and reduced tillage can help maintain soil health and ensure the long-term productivity of broccoli growing land. Crop rotation, in which broccoli is alternated with other crops in a multi-year cycle, is one of the most effective strategies for maintaining soil health. By rotating broccoli with legumes, grains, or other non-cruciferous crops, farmers can break disease and pest cycles, improve soil structure, and replenish soil nutrients. Legumes such as beans and peas are particularly valuable rotation partners for broccoli because they fix atmospheric nitrogen in the soil through a symbiotic relationship with nitrogen-fixing bacteria, reducing the need for synthetic nitrogen fertilizers. Cover cropping is another valuable practice for broccoli production. Cover crops are plants that are grown between broccoli crops primarily for the purpose of protecting and improving the soil. Cover crops prevent soil erosion, suppress weeds, improve soil structure, and add organic matter to the soil when they are incorporated into the ground. Common cover crops used in broccoli production include clover, rye, vetch, and mustard. The use of synthetic fertilizers and pesticides in broccoli production is a significant environmental concern. Synthetic nitrogen fertilizers, while effective at promoting plant growth, can contribute to water pollution when excess nitrogen runs off from fields into streams, rivers, and lakes. This nitrogen runoff can cause algal blooms, which deplete oxygen in the water and create dead zones where aquatic life cannot survive. Synthetic pesticides can also have unintended environmental effects, including harm to beneficial insects, pollinators, and other wildlife. Integrated pest management, often abbreviated as IPM, is an approach to pest control that seeks to minimize the use of synthetic pesticides while maintaining effective pest control. IPM strategies for broccoli include monitoring pest populations to determine when treatment is necessary, using biological control agents such as parasitic wasps and predatory insects to suppress pest populations, planting pest-resistant varieties, using physical barriers such as row covers to exclude pests, and applying pesticides only when other methods have failed and pest populations exceed economic thresholds. Organic broccoli production takes the principles of IPM further by prohibiting the use of synthetic pesticides and fertilizers entirely. Organic broccoli farmers rely on cultural practices, biological control, and approved organic inputs to manage pests and maintain soil fertility. While organic broccoli production typically results in lower yields and higher production costs compared to conventional production, it can offer significant environmental benefits, including reduced pesticide use, improved soil health, greater biodiversity, and lower water pollution. The carbon footprint of broccoli production is another area of environmental concern. The carbon footprint includes all greenhouse gas emissions associated with growing, harvesting, processing, transporting, and storing broccoli. The main sources of greenhouse gas emissions in broccoli production include the manufacture and application of synthetic fertilizers, which release nitrous oxide, a potent greenhouse gas, the use of fossil fuels to power farm machinery, irrigation pumps, and transportation vehicles, and the energy required for refrigeration during storage and transport. Studies have estimated that the carbon footprint of broccoli ranges from approximately 0.4 to 1.2 kilograms of carbon dioxide equivalents per kilogram of broccoli produced, depending on the production system, location, and transportation distance. This is significantly lower than the carbon footprint of most animal-based foods, which can range from 3 to more than 60 kilograms of carbon dioxide equivalents per kilogram of food produced. Choosing broccoli and other plant-based foods over animal-based foods is one of the most effective dietary strategies for reducing personal greenhouse gas emissions and mitigating climate change. Food waste is another environmental issue related to broccoli. Broccoli is a highly perishable vegetable, and significant quantities are wasted at every stage of the supply chain, from farm to fork. At the farm level, broccoli heads that do not meet cosmetic standards for size, shape, or color may be left unharvested in the field. During processing and packing, trimmings and damaged heads are discarded. During transportation and storage, broccoli can spoil if refrigeration is inadequate or if transit times are too long. At the retail level, broccoli that has passed its prime may be removed from shelves and discarded. And at the consumer level, broccoli that is purchased but not eaten before it spoils is thrown away. Reducing food waste is an important strategy for improving the environmental sustainability of broccoli production. Strategies for reducing waste include developing broccoli varieties with longer shelf life, improving cold chain management to reduce spoilage during transportation and storage, relaxing cosmetic standards to allow the sale of imperfect but perfectly nutritious broccoli, and educating consumers about proper storage techniques and creative ways to use broccoli before it goes bad. The stems and leaves of broccoli, which are often discarded by consumers, are actually highly nutritious and perfectly edible. Broccoli stems can be peeled, sliced, and eaten raw or cooked. They have a milder, slightly sweeter flavor than the florets and a crisp, crunchy texture. Broccoli leaves are similar to kale or collard greens and can be sautéed, steamed, or added to soups and stews. By eating the whole broccoli plant, rather than just the florets, consumers can reduce waste and increase their nutritional intake. Now, let us explore the role of broccoli in traditional medicine systems around the world. While modern scientific research on broccoli's health benefits is relatively recent, traditional healers and medical practitioners have recognized the therapeutic properties of cruciferous vegetables for centuries. In traditional Chinese medicine, broccoli and other members of the cabbage family are classified as cooling foods that can help clear excess heat from the body, promote detoxification, and support liver function. Traditional Chinese medicine practitioners may recommend broccoli for individuals experiencing symptoms associated with excess heat, such as inflammation, irritability, and digestive disturbance. In Ayurveda, the traditional medical system of India, vegetables from the cruciferous family are generally considered to be beneficial for the Kapha body type, which is characterized by a tendency toward sluggishness, weight gain, and congestion. Ayurvedic practitioners may recommend broccoli and other cruciferous vegetables to Kapha individuals as part of a warming, light, and energizing diet. However, Ayurveda also recognizes that raw cruciferous vegetables can be difficult to digest and may aggravate the Vata body type, which is associated with dryness, anxiety, and irregular digestion. For this reason, Ayurvedic practitioners often recommend cooking broccoli with warming spices such as ginger, cumin, and black pepper to improve its digestibility. In European folk medicine, vegetables from the cabbage family have been used for centuries as poultices and remedies for a variety of ailments. Cabbage leaves were applied to inflamed joints, wounds, and skin irritations, and the juice of cabbage family vegetables was consumed as a remedy for digestive complaints. While these traditional uses have not been rigorously tested in modern clinical trials, they reflect a long-standing folk understanding of the healing properties of cruciferous vegetables. The Greek physician Hippocrates, who lived in the 5th century before the Common Era and is often called the father of Western medicine, reportedly recommended cabbage family vegetables as a treatment for various ailments. The ancient Greek medical tradition recognized the importance of diet in maintaining health, and vegetables from the Brassica family were among the foods recommended for their perceived therapeutic properties. Roman physician Galen, who lived in the 2nd century of the Common Era, also wrote about the medicinal properties of cabbage family vegetables. Galen classified these vegetables according to their humoral properties and recommended them for treating specific conditions based on the prevailing medical theory of his time. In the medieval period, the German abbess and herbalist Hildegard von Bingen included cabbage family vegetables in her medical writings. Hildegard, who lived in the 12th century, compiled extensive knowledge of herbal medicine and dietary therapy, and her works reflect the medieval understanding of the relationship between food and health. It is important to note that while traditional medicine systems recognized the healthful properties of cruciferous vegetables long before modern science confirmed them, traditional medical claims should be evaluated critically and in light of current scientific evidence. Many traditional uses of broccoli and other cruciferous vegetables have been supported by modern research, but others have not been validated, and some traditional claims may be based on outdated or incorrect medical theories. Let us now address the psychology of taste and explore why broccoli is one of the most divisive vegetables in the world. Why do some people love broccoli while others absolutely cannot stand it? The answer lies in a complex interplay of genetics, biology, psychology, culture, and personal experience. As we discussed in Part 1, genetic variation in the TASTOR38 gene affects how people perceive the bitter compounds found in broccoli and other cruciferous vegetables. People who carry 2 copies of the taster variant of this gene, known as PAV homozygotes, are particularly sensitive to bitter tastes and are more likely to find broccoli unpleasantly bitter. People who carry 2 copies of the non-taster variant, known as AVI homozygotes, are less sensitive to bitter tastes and are more likely to enjoy broccoli. People who carry 1 copy of each variant, known as PAV-AVI heterozygotes, fall somewhere in between. It is estimated that approximately 25% of the population are supertasters, who are highly sensitive to bitter compounds. Approximately 50% are medium tasters, and approximately 25% are non-tasters who have low sensitivity to bitter compounds. These proportions vary across different ethnic and geographic populations, reflecting the evolutionary history of taste perception in different human groups. The evolutionary basis for bitter taste sensitivity is thought to be related to the detection of potentially toxic substances in food. Many naturally occurring toxins, including alkaloids and certain glucosinolates, have a bitter taste. The ability to detect these bitter compounds and avoid consuming potentially dangerous foods would have been a significant survival advantage for our ancestors. However, in the modern world, where broccoli and other bitter-tasting vegetables are known to be safe and nutritious, this heightened bitter sensitivity can be a disadvantage, as it may lead people to avoid eating healthy foods. Beyond genetics, there are many other factors that influence broccoli preference. Childhood experiences with broccoli play a significant role in shaping lifelong attitudes toward the vegetable. Children who are exposed to broccoli at an early age and who see their parents and other role models eating and enjoying broccoli are more likely to develop a positive attitude toward the vegetable. Conversely, children who are forced to eat broccoli against their will or who have negative experiences associated with broccoli, such as being punished for not finishing their vegetables, may develop a lasting aversion to the food. Research in developmental psychology has shown that children are innately neophobic when it comes to food, meaning that they tend to reject new and unfamiliar foods. This food neophobia is thought to be an evolutionary adaptation that protected young children from eating potentially harmful substances. Broccoli, with its strong flavor, unfamiliar texture, and unusual appearance, is particularly likely to trigger food neophobia in young children. However, repeated exposure to broccoli, ideally in a positive and pressure-free context, can gradually overcome this neophobia and lead to acceptance and even enjoyment of the vegetable. Studies have shown that it can take 10 to 15 exposures to a new food before a child accepts it. This means that parents who give up after their child rejects broccoli once or twice are not giving the child enough opportunities to develop a taste for the vegetable. Patient repeated exposure, combined with positive role modeling and a relaxed mealtime atmosphere, is the most effective strategy for encouraging children to eat broccoli and other vegetables. The way broccoli is prepared also has a major impact on its acceptability. As we discussed in Part 1, overcooked broccoli has a mushy texture and a strong sulfurous odor that many people find unappealing. Lightly steamed, stir-fried, or roasted broccoli, on the other hand, has a pleasant texture and a milder, more appealing flavor. Many people who believe they dislike broccoli have only ever eaten it overcooked, and they may discover that they actually enjoy it when it is prepared properly. Adding flavor-enhancing ingredients to broccoli can also improve its palatability. Garlic, lemon juice, soy sauce, Parmesan cheese, butter, olive oil, chili flakes, sesame oil, and toasted nuts are all popular additions that can transform broccoli from a bland side dish into a delicious and craveable food. The key is to find preparations that appeal to individual tastes and preferences, rather than insisting that broccoli must be eaten plain and unadorned. Cultural factors also play a role in broccoli acceptance. In cultures where broccoli is a traditional and widely consumed vegetable, people tend to have more positive attitudes toward it. In cultures where broccoli is a relatively recent introduction, it may be viewed with more suspicion and resistance. The global spread of broccoli in the 20th and 21st centuries has introduced the vegetable to many populations that had no prior experience with it, and the process of cultural acceptance is still ongoing in some regions. The visual appearance of broccoli can also affect people's willingness to eat it. The dense clusters of tiny flower buds that make up the broccoli head can be off-putting to some people, particularly children, who may associate the unusual texture with unpleasant sensations. On the other hand, the tree-like shape of broccoli florets has been used creatively by parents and educators to make the vegetable more appealing to children. Telling children that they are eating tiny trees or creating broccoli forests on the plate can spark imagination and curiosity, making the eating experience more enjoyable. Let us now turn to some of the myths and misconceptions about broccoli that persist in popular culture and address them with scientific evidence. One common myth is that frozen broccoli is significantly less nutritious than fresh broccoli. This is not true. As we discussed in Part 1, commercially frozen broccoli is blanched and frozen shortly after harvest, which preserves most of its vitamins, minerals, and phytochemicals. In fact, frozen broccoli may actually be more nutritious than fresh broccoli that has been stored for several days after harvest, as the nutrient content of fresh broccoli declines over time during storage. Multiple studies have confirmed that the nutritional differences between fresh and frozen broccoli are small and that both forms are excellent choices for a healthy diet. Another myth is that organic broccoli is always more nutritious than conventionally grown broccoli. The evidence on this topic is mixed. Some studies have found that organic broccoli contains higher levels of certain nutrients and phytochemicals, particularly vitamin C and glucosinolates, while other studies have found no significant differences. The nutritional content of broccoli is influenced by many factors, including the variety, growing conditions, soil quality, and harvest timing, and these factors can vary widely both within and between organic and conventional production systems. While organic broccoli may offer environmental benefits such as reduced pesticide use and improved soil health, the nutritional differences between organic and conventional broccoli are generally small and should not be the primary factor in purchasing decisions. A third myth is that you must eat broccoli raw to get its full health benefits. While raw broccoli does retain the highest levels of certain heat-sensitive nutrients, such as vitamin C and myrosinase enzyme activity, cooking broccoli also has benefits. Cooking breaks down the tough cell walls of the broccoli, making its nutrients more accessible and easier to absorb. Cooking also improves the digestibility of broccoli and can enhance the flavor, making it more likely that people will eat it in sufficient quantities. The best approach is to eat broccoli in a variety of forms, both raw and cooked, to maximize the range of nutrients and phytochemicals you consume. A fourth myth is that broccoli causes kidney stones. This misconception arises from the fact that broccoli contains oxalates, compounds that can contribute to the formation of calcium oxalate kidney stones in susceptible individuals. However, the oxalate content of broccoli is relatively low compared to other vegetables, such as spinach, beets, and rhubarb. For most people, eating broccoli does not increase the risk of kidney stones, and the calcium in broccoli may actually help prevent kidney stone formation by binding to oxalates in the digestive tract and preventing their absorption into the bloodstream. People with a history of calcium oxalate kidney stones should consult their healthcare provider for personalized dietary advice, but for the general population, broccoli is a safe and healthful food. A fifth myth is that broccoli is dangerous for people with thyroid disorders. As we discussed in Part 1, broccoli contains goitrogens that can theoretically interfere with thyroid hormone production. However, the goitrogenic effect of broccoli is weak, and it would require consuming extremely large quantities of raw broccoli on a regular basis to have any meaningful impact on thyroid function. Cooking broccoli significantly reduces its goitrogen content, further minimizing any potential risk. People with thyroid disorders should not avoid broccoli, but should discuss their dietary choices with their healthcare provider to ensure that they are maintaining adequate iodine intake. A sixth misconception is that the broccoli stem is not nutritious or edible. In reality, the broccoli stem is perfectly edible and contains many of the same nutrients found in the florets, including vitamin C, fiber, and glucosinolates. The stem has a milder, slightly sweeter flavor than the florets and can be peeled, sliced, and eaten raw, steamed, stir-fried, roasted, or added to soups and stews. Discarding the stem is a waste of both nutrition and money. A seventh myth is that broccoli loses all of its nutrients when it is microwaved. While microwaving can result in some nutrient loss, particularly if large amounts of water are used, it is actually one of the better cooking methods for preserving nutrients, because the short cooking time and minimal water exposure help retain vitamins and phytochemicals. Studies have shown that microwaving broccoli with little or no added water preserves more vitamin C and glucosinolates than boiling. Now let us delve into some truly surprising and lesser-known facts about broccoli that will expand your understanding of this vegetable. Broccoli has been shown to contain compounds that can influence gene expression through epigenetic mechanisms. Epigenetics is the study of changes in gene activity that do not involve changes to the DNA sequence itself. These epigenetic changes can affect how genes are turned on or off, and they play a critical role in health, development, and disease. Sulforaphane, the star phytochemical in broccoli, has been shown to act as an epigenetic modifier, specifically as a histone deacetylase inhibitor. Histone deacetylases are enzymes that modify the proteins around which DNA is wrapped, affecting the accessibility of genes for transcription. By inhibiting these enzymes, sulforaphane can influence the expression of genes involved in cell growth, differentiation, and defense, potentially promoting a pattern of gene expression that favors health. Broccoli contains a surprisingly complex array of volatile compounds that contribute to its distinctive aroma and flavor. Scientists have identified more than 50 different volatile compounds in broccoli, including aldehydes, alcohols, ketones, esters, terpenes, and sulfur-containing compounds. The specific combination and concentration of these volatiles varies depending on the broccoli variety, growing conditions, maturity at harvest, and cooking method. The sulfur-containing volatiles, including dimethyl disulfide and dimethyl trisulfide, are primarily responsible for the characteristic cabbage-like smell of cooked broccoli, while other volatiles contribute fresh, green, or floral notes to the aroma profile. Broccoli is one of the few vegetables that contains measurable amounts of the amino acid sulforaphane. While we have discussed sulforaphane extensively as a phytochemical, it is worth noting that sulforaphane is not technically an amino acid, but rather an isothiocyanate. However, the sulfur-containing amino acids methionine and cysteine, which are present in broccoli protein, serve as metabolic precursors for the synthesis of glucosinolates, the compounds from which sulforaphane is derived. This highlights the interconnected nature of broccoli's nutritional components, where amino acids, glucosinolates, and isothiocyanates are all part of the same metabolic network. Broccoli has been studied for its potential to support liver health. The liver is the body's primary detoxification organ, responsible for processing and eliminating a wide range of toxins, drugs, and metabolic waste products. Research has shown that sulforaphane and other compounds in broccoli can support liver function by enhancing the activity of phase II detoxification enzymes, which play a critical role in neutralizing and eliminating harmful substances from the body. Animal studies have demonstrated that broccoli consumption can protect the liver from damage caused by various toxins, and that it may help reduce the accumulation of fat in the liver, a condition known as non-alcoholic fatty liver disease that is becoming increasingly prevalent worldwide. Broccoli has also been investigated for its potential effects on respiratory health. The lungs are constantly exposed to air pollutants, allergens, and pathogens, and the antioxidant and anti-inflammatory compounds in broccoli may help protect lung tissue from damage. A clinical trial published in the journal Clinical Immunology found that broccoli sprout extract reduced markers of airway inflammation in participants exposed to diesel exhaust particles, suggesting that broccoli-derived compounds may help protect against the harmful effects of air pollution on the lungs. The relationship between broccoli and gut health extends beyond the fiber and prebiotic effects we discussed in Part 1. Research has revealed that the aryl hydrocarbon receptor, a protein that plays a critical role in intestinal barrier function and immune regulation, is activated by compounds produced during the digestion of broccoli. When broccoli is digested, certain metabolites interact with the aryl hydrocarbon receptor in the cells lining the intestine, triggering a cascade of immune and protective responses that help maintain the integrity of the gut barrier. A healthy gut barrier is essential for preventing harmful bacteria and toxins from crossing from the intestine into the bloodstream, and disruption of the gut barrier has been linked to a wide range of health problems, including inflammatory bowel disease, allergies, and autoimmune conditions. Broccoli has been shown to have antimicrobial properties. Research has demonstrated that sulforaphane and other isothiocyanates from broccoli can inhibit the growth of a variety of bacteria, fungi, and parasites. As we mentioned in Part 1, sulforaphane has been shown to be particularly effective against Helicobacter pylori, the bacterium responsible for stomach ulcers. But research has also found that broccoli-derived compounds can inhibit the growth of Staphylococcus aureus, Escherichia coli, and other pathogenic bacteria. These antimicrobial properties add another dimension to broccoli's health-promoting capabilities. Broccoli seeds contain exceptionally high concentrations of glucosinolates, even higher than those found in broccoli sprouts or mature broccoli heads. Broccoli seed extracts are now available as dietary supplements and are marketed for their concentrated sulforaphane content. However, it is important to note that the bioavailability and effectiveness of sulforaphane from supplements may differ from that obtained from whole broccoli or broccoli sprouts, and more research is needed to determine the optimal form and dosage for health benefits. The economic value of broccoli extends far beyond the fresh vegetable market. Broccoli is used as a raw material for a growing number of value-added products, including broccoli powder, broccoli extract supplements, broccoli seed oil, and even broccoli-based cosmetics and skincare products. Broccoli seed oil extracted from the seeds of the broccoli plant is rich in a unique fatty acid called erucic acid and contains high levels of vitamin A and vitamin C, it has gained popularity in the natural beauty industry as a lightweight, non-greasy moisturizer that can add shine to hair and soften skin. Let us now examine the role of broccoli in addressing some of the most pressing public health challenges of our time. Obesity is one of the most significant public health challenges facing the modern world. The prevalence of obesity has increased dramatically in recent decades, driven by the widespread availability of calorie-dense, nutrient-poor foods and increasingly sedentary lifestyles. Broccoli, with its low calorie content and high nutrient density, is an ideal food for people who are trying to manage their weight. A large serving of broccoli provides a satisfying volume of food with relatively few calories, helping to create a feeling of fullness that can reduce overall calorie intake. The fiber in broccoli slows digestion and prolongs the feeling of satiety, further supporting weight management goals. Research has also suggested that the sulforaphane in broccoli may have direct effects on fat metabolism. Animal studies have shown that sulforaphane can reduce the accumulation of body fat, enhance the activity of fat-burning enzymes, and improve insulin sensitivity. While these findings need to be confirmed in human clinical trials, they suggest that broccoli may offer benefits for weight management that go beyond its low-calorie content. Diabetes is another major public health concern that may be addressed in part through dietary strategies involving broccoli. As we discussed in Part 1, sulforaphane has been shown to improve insulin sensitivity and reduce fasting blood sugar levels in some clinical trials. The fiber in broccoli also helps regulate blood sugar by slowing the absorption of glucose from the digestive tract. For people with diabetes or prediabetes, incorporating broccoli into the diet can be a simple and effective strategy for supporting blood sugar management. Chronic inflammation is increasingly recognized as a root cause of many modern diseases, including heart disease, diabetes, arthritis, and neurodegenerative conditions. The anti-inflammatory compounds in broccoli, including sulforaphane, kaempferol, and omega-3 fatty acids, can help reduce chronic inflammation and lower the risk of inflammation-driven diseases. A diet rich in anti-inflammatory foods like broccoli, combined with regular physical activity, adequate sleep, and stress management, is one of the most effective strategies for reducing chronic inflammation and promoting long-term health. Eye health is another area where broccoli can make a meaningful contribution. As we discussed in Part 1, broccoli contains the carotenoids lutein and zeaxanthin, which are critical for protecting the macula of the eye from damage caused by blue light and oxidative stress. Age-related macular degeneration is a leading cause of vision loss in older adults, and adequate intake of lutein and zeaxanthin has been associated with a reduced risk of this condition. Broccoli is one of the best dietary sources of these protective carotenoids, and regular consumption can help support healthy vision throughout life. Dental health is a lesser-known area where broccoli may offer benefits. The iron in broccoli has been shown to help form an acid-resistant film on the surface of tooth enamel, which can protect teeth from the acid-producing bacteria that cause cavities. Additionally, the vitamin C in broccoli supports healthy gums by promoting collagen synthesis and reducing inflammation. The crunchy texture of raw broccoli also provides a natural cleaning action on the teeth, helping to remove plaque and food particles. Let us now consider broccoli's role in the diets of specific populations, including pregnant women, children, older adults, and athletes. For pregnant women, broccoli is an exceptionally valuable food. The folate in broccoli is critical for preventing neural tube defects in the developing fetus, and the iron supports the increased blood volume that occurs during pregnancy. The calcium in broccoli helps build the baby's bones and teeth, while the vitamin C enhances iron absorption and supports the mother's immune system. The fiber in broccoli can help prevent the constipation that is common during pregnancy. And the choline in broccoli, a nutrient that is important for fetal brain development, adds yet another dimension to broccoli's value during pregnancy. For children, broccoli is one of the most nutritious vegetables available, providing essential vitamins and minerals that are critical for growth and development. The challenge, as we discussed earlier, is that many children are initially resistant to eating broccoli. Parents can help overcome this resistance by offering broccoli frequently, preparing it in appealing ways, modeling positive eating behaviors, and involving children in the growing and cooking of broccoli. Research has shown that children who are involved in growing vegetables in a garden or helping to prepare vegetables in the kitchen are more likely to eat and enjoy those vegetables. For older adults, broccoli offers several important benefits. The vitamin K and calcium in broccoli support bone health and may help reduce the risk of osteoporosis and fractures. The antioxidants and anti-inflammatory compounds in broccoli may help protect against age-related cognitive decline and neurodegenerative diseases. The fiber in broccoli supports digestive health, which can be a concern for older adults who may be more susceptible to constipation and other digestive problems. And the overall nutrient density of broccoli helps ensure that older adults who may eat less food overall still receive adequate nutrition. For athletes and physically active individuals, broccoli provides a wealth of nutrients that support exercise performance and recovery. The vitamin C in broccoli supports immune function, which can be compromised by intense training. The potassium helps maintain proper hydration and prevent muscle cramps. The anti-inflammatory compounds in broccoli can help reduce exercise-induced inflammation and support faster recovery. And the low-calorie, high-nutrient profile of broccoli makes it an ideal food for athletes who need to maximize nutrient intake while managing calorie consumption. Now, let us explore some of the most creative and unexpected uses of broccoli that go beyond the kitchen. Broccoli has been used as a natural dye. The deep green color of broccoli comes from chlorophyll, and this pigment can be extracted and used to color fabrics, yarns, and other materials. While broccoli-based dyes are not as widely used as synthetic dyes, they offer a natural, non-toxic alternative for environmentally conscious crafters and textile artists. Broccoli has also been used in scientific education and research as a model organism for studying plant biology, genetics, and biochemistry. Its relatively short growing cycle, ease of cultivation, and well-characterized genome make it a useful tool for teaching and research in agricultural science and biology. In the world of art, broccoli has been the subject of numerous paintings, photographs, and sculptures. The fractal-like structure of Romanesco broccoli, in particular, has captivated artists and mathematicians alike with its mesmerizing spiraling patterns. Romanesco broccoli is often cited as one of the most beautiful examples of fractal geometry in nature, and its image has been used in mathematical education to illustrate concepts such as self-similarity and the Fibonacci sequence. The Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding ones, 1, 1, 2, 3, 5, 8, 13, 21, and so on. The spiraling florets of Romanesco broccoli are arranged in a pattern that follows the Fibonacci sequence, creating a visually stunning display of mathematical precision in nature. This connection between broccoli and mathematics has made Romanesco broccoli a popular subject for science communicators and educators seeking to demonstrate the beauty and order that underlie the natural world. Broccoli has also made appearances in popular media, including films, television shows, books, and video games. It is often used as a symbol of healthy eating, and its distinctive appearance makes it instantly recognizable. In animated films and children's television, broccoli is frequently depicted as the vegetable that children love to hate, a cultural trope that has both reinforced and challenged perceptions of broccoli as a food for children. In the world of competitive eating, broccoli has made occasional appearances as a contest food. While it is not as commonly featured as hot dogs, pies, or watermelons, broccoli eating contests have been held at various food festivals and events, adding a healthy twist to the competitive eating tradition. Broccoli has even been grown in space. In ongoing research into space agriculture, scientists have experimented with growing broccoli and other vegetables in microgravity conditions aboard the International Space Station. The ability to grow fresh vegetables in space is considered essential for long-duration space missions, such as future missions to Mars, where carrying sufficient food supplies from Earth would be impractical. Broccoli's high nutrient density and relatively compact growth habit make it a promising candidate for space agriculture, and research into growing broccoli in controlled environment systems has yielded promising results. Let us now take a moment to celebrate the farmers who grow broccoli and the vital role they play in bringing this nutritious vegetable to our tables. Broccoli farming is demanding work that requires skill, knowledge, patience, and resilience. Broccoli farmers must contend with unpredictable weather, pest and disease pressures, market fluctuations, and the physical demands of growing and harvesting a perishable crop. Despite these challenges, broccoli farmers take enormous pride in their work and in the quality of the product they deliver to consumers. In many broccoli-producing regions, farming is a family tradition that has been passed down through generations. Families who have grown broccoli for decades or even centuries possess a deep, intuitive understanding of the crop and the land that cannot be replicated by textbooks or technology alone. This generational knowledge is a valuable resource that contributes to the quality and sustainability of broccoli production. At the same time, broccoli farming is increasingly influenced by technology and innovation. Precision agriculture technologies such as GPS-guided tractors, drone-based crop monitoring, soil sensors, and data analytics are helping broccoli farmers optimize their operations, reduce waste, and improve efficiency. Robotic harvesting systems are being developed to address labor shortages and reduce the physical demands of broccoli harvesting. Although the technology is still in its early stages and hand harvesting remains the standard in most broccoli-producing regions. The workers who harvest broccoli deserve special recognition for their vital contribution. In many countries, broccoli is harvested by teams of seasonal agricultural workers who perform physically demanding work under challenging conditions. These workers bend, stoop, and reach for hours each day, carefully selecting and cutting mature broccoli heads by hand. Their skill and speed are essential for ensuring that broccoli is harvested at the peak of quality and delivered to consumers in the best possible condition. Fair treatment, safe working conditions, and adequate compensation for agricultural workers are important issues that deserve attention and action from consumers, policymakers, and the agricultural industry. Now let us discuss some practical tips for selecting, storing, and preparing broccoli to maximize its quality and nutritional value. When selecting broccoli at the market, look for heads that are firm and compact with tightly closed buds. The color should be a deep, dark green, sometimes with a slight purple or blue-green tint. Avoid heads that have yellow or open buds, as these are signs that the broccoli is past its prime and will have a stronger, more bitter flavor. The stems should be firm and fresh-looking, without any signs of sliminess, discoloration, or drying. The leaves, if present, should be crisp and green, not wilted or yellowed. Size is not necessarily an indicator of quality. Small and large heads can both be excellent as long as they are fresh and firm. However, very large heads with thick woody stems may be tougher and less tender than smaller heads with thinner stems. Once you bring broccoli home, store it in the refrigerator as soon as possible. Unwashed broccoli can be stored in a loosely sealed plastic bag in the crisper drawer for up to 5 to 7 days. Avoid washing broccoli before storage, as the excess moisture can promote mold growth and accelerate spoilage. If the broccoli starts to show signs of yellowing or wilting, use it immediately, as these are signs that its quality is declining. To prepare broccoli, start by rinsing it under cool running water to remove any dirt or debris. Cut the florets from the main stem, leaving about 2 to 3 centimeters of stem attached to each floret. The remaining stem can be peeled to remove the tough outer layer, then sliced or diced for cooking. The florets and stems can be cooked separately or together, depending on your preference and the recipe you are using. As we discussed in Part 1, the cooking method you choose has a significant impact on the nutritional value and flavor of broccoli. Steaming is generally considered the best method for preserving nutrients, while roasting produces the most flavorful results. Stir-frying is an excellent compromise between nutrient preservation and flavor development. Boiling is the least desirable method from a nutritional standpoint, but it can still produce acceptable results if cooking time is kept to a minimum and the cooking water is used in the dish. A few additional cooking tips can help you get the most out of your broccoli. First, do not overcook it. Broccoli should be cooked until it is tender crisp, meaning that it yields slightly when pierced with a fork but still has a slight crunch. Overcooked broccoli is mushy, sulfurous, and unappealing, and it has lost a significant portion of its nutrients. Second, season broccoli generously. A pinch of salt, a squeeze of lemon juice, a drizzle of olive oil, or a sprinkle of Parmesan cheese can transform plain broccoli into a delicious and satisfying dish. Third, do not be afraid to experiment with different preparations and flavor combinations. Broccoli is an incredibly versatile vegetable that pairs well with a wide range of flavors, from Asian-inspired soy and ginger to Mediterranean olive oil and garlic to rich and creamy cheese sauces. Let us also address the question of how much broccoli you should eat for optimal health. Most dietary guidelines recommend consuming at least 5 servings of fruits and vegetables per day, and cruciferous vegetables like broccoli should be a regular part of this intake. Nutritional experts generally suggest eating cruciferous vegetables at least 3 to 5 times per week, with a serving size of about 1 cup of chopped broccoli. However, there is no strict upper limit on broccoli consumption for most healthy individuals, and eating broccoli daily can be part of a healthy, balanced diet. Some researchers have suggested that consuming broccoli or broccoli sprouts daily may be beneficial for maximizing the intake of sulforaphane and other health-promoting phytochemicals. The effects of sulforaphane are relatively short-lived in the body, as it is metabolized and excreted within about 24 hours of consumption. This means that regular, consistent intake of broccoli is more effective for maintaining high levels of sulforaphane in the body than occasional, sporadic consumption. For individuals who do not enjoy eating broccoli, broccoli sprout supplements and broccoli extract capsules are available as alternatives. However, whole food sources of broccoli are generally preferred over supplements, as they provide a complex mix of nutrients, fiber, and phytochemicals that work together synergistically to promote health. The health benefits of broccoli are likely due to the combined effects of its many components, rather than any single nutrient or compound in isolation. Let us now look forward and consider the future of broccoli in the context of evolving food systems, changing consumer preferences, and emerging scientific discoveries. The future of broccoli looks bright. Consumer awareness of the health benefits of broccoli is higher than ever, and demand for broccoli continues to grow worldwide. Advances in plant breeding, agricultural technology, and food processing are making broccoli more productive, more nutritious, more widely available, and more convenient than at any previous time in history. One of the most promising developments is the growing interest in broccoli microgreens and sprouts. These young broccoli plants, harvested just days after germination, are packed with concentrated levels of sulforaphane and other beneficial phytochemicals. They can be grown easily at home with minimal equipment, making them accessible to anyone with a sunny windowsill and a few days of patience. The growing popularity of home sprouting and microgreen growing reflects a broader trend toward local, sustainable, and health-conscious food production. The development of new broccoli varieties with enhanced nutritional profiles, improved flavor, and greater adaptability to diverse growing conditions will continue to be a priority for plant breeders and agricultural researchers. Climate-resilient broccoli varieties that can tolerate higher temperatures, drought, and other environmental stresses will be essential for maintaining broccoli production in a warming world. The integration of broccoli into new food products and formats will also continue to evolve. Broccoli-based snacks, beverages, pasta, and other processed foods are becoming increasingly common, making it easier for consumers to incorporate broccoli into their diets in convenient and enjoyable ways. Food scientists are also exploring ways to extract and concentrate the beneficial compounds in broccoli for use in functional foods, dietary supplements, and even pharmaceutical applications. The scientific understanding of broccoli's health benefits will continue to deepen as new research is conducted. Clinical trials examining the effects of broccoli and broccoli-derived compounds on specific health conditions are ongoing, and the results of these studies will provide more definitive evidence about the role of broccoli in disease prevention and health promotion. Emerging areas of research, including the effects of broccoli on the gut microbiome, epigenetics, brain health, and aging, hold particular promise and could lead to new insights that further elevate broccoli's status as a health-promoting food. The story of broccoli is ultimately a story about the relationship between humans and the natural world. For thousands of years, we have cultivated, selected, and refined this plant, shaping it to meet our needs and preferences. In return, broccoli has nourished us, sustained us, and provided us with a remarkable array of health-promoting compounds that protect our bodies and enhance our well-being. Every head of broccoli that you eat is the product of centuries of human effort and ingenuity. It carries within it the genetic legacy of ancient wild plants, the wisdom of countless generations of farmers, and the cutting-edge insights of modern science. It is a living testament to the power of agriculture, the generosity of nature, and the enduring human quest for health and nourishment. As we bring this documentary to a close, let us reflect on what we have learned. We have traced the origins of broccoli from a wild Mediterranean plant to a global dietary staple. We have explored its extraordinary nutritional profile and the scientific evidence behind its many health benefits. We have examined the genetics and breeding of broccoli, the environmental considerations of its production, and the cultural and psychological factors that influence our relationship with this vegetable. We have debunked myths, shared practical tips, and looked ahead to the future of broccoli in a rapidly changing world. Through it all, one message has emerged clearly: broccoli is one of the most remarkable foods available to us. It is a nutritional powerhouse that delivers an extraordinary concentration of vitamins, minerals, fiber, and health-promoting phytochemicals in every bite. It is a versatile culinary ingredient that can be prepared in countless ways to suit every taste and occasion. And it is a sustainable food choice that nourishes our bodies while treading lightly on the planet. Whether you are a lifelong broccoli lover or someone who has been skeptical of this green vegetable, we hope that this documentary has given you a new appreciation for the extraordinary qualities of broccoli. We hope it has inspired you to include more broccoli in your diet, to experiment with new preparations and recipes, and to share the story of broccoli with your friends and family. The next time you see a head of broccoli in the market, take a moment to appreciate the incredible journey it has taken to reach you. Think of the ancient Romans who first cultivated it in their gardens. Think of the monks who preserved it through the Middle Ages. Think of the Renaissance cooks who introduced it to new audiences. Think of the scientists who are unlocking its secrets in laboratories around the world. And think of the farmers who wake before dawn to tend their fields and harvest the crop that will nourish you and your family. Broccoli is more than a vegetable. It is a gift from history, from nature, and from the human spirit of curiosity and care. It is a small green wonder that has traveled across oceans and centuries to land on your plate. Cherish it, enjoy it, and share its story. Thank you for watching. Thank you for joining us on this extraordinary journey through the world of broccoli. We hope you have enjoyed every moment of this documentary and that it has enriched your understanding of one of the world's most remarkable foods. Please remember to subscribe to our channel for more history videos and documentaries in the future. Share your thoughts in the comments below. Tell us your favorite way to prepare broccoli. Tell us about your relationship with this incredible vegetable. And share this video with someone who needs to hear the story of broccoli. Until next time, eat well, live well, and never underestimate the power of a humble green vegetable to change the world.